Hello everyone, welcome to the program on building AI apps using Streamlit and Python. End users have been implicitly asking for a simple web app to view the results of AI algorithms, and data scientists have been looking for a platform to build AI web apps easily and faster. Streamlit addresses both these needs perfectly. We are going to begin the session discussing the need for AI web apps. We are then going to deep dive on the functionalities of Streamlit. I will be demonstrating how to build real-world apps in the areas of healthcare, NLP, sales forecasting, EDA. I will also be covering how to host these apps in cloud platform like Heroku. If you are new to the world of AI, I encourage you to go through the concepts like machine learning, logistic regression, NLP, and EDA before you start the video lectures related to Streamlit. There is extensive coverage of Python too. Both are available in the later part of the program. All in all, this program can be pursued by both experienced and people who are new to AI. I'm Govin, and I come with over 2 decades of experience managing quality, operations, and technology in MNCs and startups. I'll be bringing my real-world experiences managing and deploying AI solutions into this program. So let's get started. If you see the AI landscape, it is evolving fast. I will say that these are still early days in AI. So the focus has been on building models and analyzing data. Though many packages are available to create graphs and powerful visualizations, data scientists sometimes don't talk the language of users and stakeholders who want to see the outcome in the form of crisp tables, graphs, and powerful visualizations. Often, it is due to lack of web-related technical skills like JavaScript, HTML, CSS, etc. on the part of data scientists. We can't blame them too, as one can't be a master of multiple technologies. An app that helps end users to upload data and see the results for themselves is actually a strong need. Since there can be multiple end users who may even be outside of the data scientist organization, this app needs to be a web-based app. Moreover, end users are comfortable with a web app, and a web app is an expectation too. In the previous session, we saw the need for a web app for AI. In this session, we will see the need for a platform like Streamlit. If you look at the requirements for developing a web app for artificial intelligence, we need to take care of these 5 things. The most important, according to me, is the tech stack. Web and AI skills are rarely pursued by same set of people. So we really need a large team of AI and web developers to develop an AI web app. This challenge is addressed by Streamlit. Streamlit actually takes care of all of these requirements. It is easy to create a user interface as well as hosting the application. You don't need to worry about the backend too. So everything that is needed for an AI web app is taken care of by Streamlit. In many ways, Streamlit is similar to R-Shiny, and in my opinion, it's a lot easier than R-Shiny. I'm going to demonstrate a range of apps from NLP to disease prediction to sales forecasting, and you are going to see how easy it is with Streamlit. In this session, let us understand the infrastructure that is needed for building Streamlit apps. We need to download Anaconda. You can search for the same in Google. When you click this, it will take you to the download page and you can download the individual edition for Windows. Please note that it takes a while for Anaconda to get installed. Please be patient and do not stop the install process midway. The other thing we need is Notepad to write the Python programs. We will save the Notepad as .py file. Search for Notepad++ in Google and go for the latest release. And you are good to go. Both Anaconda Individual Edition and Notepad are free to use. Once you have installed Anaconda, you can install Streamlit using Anaconda's command prompt itself. You access the Anaconda's command prompt using the start menu, and you can give pip install Streamlit command in Anaconda prompt itself to install Streamlit. You can install other libraries too, like NumPy, Pandas, here itself. Okay, so now we are ready to start coding for building the Streamlit app. In this session, we are going to create our first web app using Streamlit. All that we are going to do in that web app is to display Hello World. You may be aware that Hello World is what we normally print first in any programming language, including Python. Okay, and I have typed the necessary commands in my notepad. Okay, so the first step I need to do is import Streamlit as st. That is the first step that I do. Then st.text will display Hello World. What I am trying to do here, these two, is whatever gets printed as Hello World, I am trying to change the font size and font color. That's all I am trying to do. For that I am using Markdown, st.markdown. That's what I am trying to do here. Okay. Now let's try to save this. I am going to save this in Streamlit folder that I have created in my desktop. Okay, this is the Streamlit folder. As you can see here, it is in desktop and it is this is the Streamlit folder. What you're seeing here is other apps that I'm going to be showing towards the later part of the session, later part of this program. The initial part of the program is going to introduce you to various options in Streamlit. That's what we are doing now. Okay. Now let's save this notepad. Okay. Let's save this file. Save as. We will give app is already there. So we will give app as a file name is already there. So we will give app2.py. Okay. You can save. Now this is saved. Okay. Now let's come and see here. App2 is there. Okay. Now we are going to run this app. Okay. We have created in Python. We have typed this in Notepad. Now we have to run this. Only then we can see the output, which is the web app, right? We have already installed Anaconda. Now for running this file, we go to Start menu and then Anaconda prompt. Okay, right? Now we have to reference the file that is stored in Streamlit folder, which is there in desktop. For that, we change the directory cd desktop, right? Right now, before this command, the directory is pointing to C users Kumar. Okay, we need to change the directory to desktop first and then to Streamlit. Okay, now we are ready to run. So the command is Streamlit run app2.py. We are running it now. Very shortly, you will see the link using which we can access the app. In fact, the app will open in the default Chrome browser, right? You can see here the URL to access the app, the local URL and the network URL is there. And the app has opened in the default browser, which is nothing but Chrome in my case. Okay, and you can see here hello world, and then we have changed the color and the font size, right? So this is our first app. Okay, hello world, we have created our first and a very simple web app. We will slowly add other functionalities and test it. Okay, and after that we will get into projects. If you see here, there is option to rerun, clearing the cache, deploying the app, right? You can even record this entire thing, which I'm going to demonstrate a little later. And then you have settings. Okay, so these are the options that are available in Streamlit. Okay, very simple, right? Now let's see and make some changes and see how Streamlit operates. Okay, instead of hello world, we will say hello, right? Or say good morning. Let's go and do that. Okay, instead of hello world, we will say good morning. Morning, we will mention it here, right? All that you need to do is, because you have made the change, come here, save it. You don't need to rerun the file, you just have to refresh. As you can see here, source file has changed, right? You get this message. Okay, rerun, always rerun, these options are there. Now let's rerun and you have good morning, right? In this session, we are going to create headers, subheader, title, and also warning and success messages. As you may be aware, in any app, you will have successful processing of data or information. If data is not properly processed, it will raise an error or it may throw a warning. Okay, we want these kind of options to be available in our app, right? Because we are looking at developing a full-fledged app, right? In addition to that, we will also have header and subheader and also title for the app. So that's what we are going to create in this session, right? Our first step is, of course, import Streamlit as ST. Now what we are going to do is we are going to save this file, okay, as a new app. Then we are going to run the app in the command prompt. That's what we are going to do. Okay, now let us save this file in Streamlit folder. Let's call this as app3.py. Okay, we have saved it. Let's see if the file is there. Yeah, app3.py file is there. Now let's go to Anaconda prompt and run this. Let's change the directory. cd Streamlit. Now let's run it. You need to first start with Streamlit, run app3.py. I'm demonstrating this once again because I want you to be very clear with how to write the command, how to save the file in a folder, reference that folder in command prompt, and then run it. Okay. Now I'll click enter. You will have the local URL and network URL that has come, and it's also opening in my default browser. See here, beautifully it has come. Header, subheader, you can give different names also, right? Title, this is something we saw earlier too. Markdown, and then success, warning, and error. If you see, these are in different colors. And if you want, you can change these colors and the font size using what I described in the earlier session. Clear? Simple, right? This is also a web app. If you see, this is also a web app. All we are doing is we are displaying certain words. Okay, we will slowly build additional options and complexity. What you're going to see in the project is you're going to actually upload a file. Machine learning algorithm is going to run in the backend, and you're going to see the results. How beautiful it is, right? Okay. In this session, we will see how to access a file that is stored in the folder and also display the contents of that file. When I'm referring to contents, I'm referring to data because we are interested in developing an AI app. So obviously we are interested in data, and the file that we are going to read is a CSV file. Okay, we're going to reference a file that is stored in a folder, read it, and then display the contents in our web app. That's what we are going to do. Okay, so this is the app that we created in the previous session. I'm going to use the same app. That is, I'm going to delete all this and write code for reading a file and then displaying the contents of the file. Okay, these are the set of commands that are of relevance as far as the previous session is concerned and the current app that is there, right? That is header, subheader, success, warning, and error. Okay, now I'm going to delete them. Okay, all I have to do is I have to save this and then rerun. You see here, source file has changed. Let's rerun. Oh, we're getting an error here. Okay, this is something you must learn. Okay, debugging is both a science as well as an art. I've got an error. Now let's see what the error is. Name st is not defined. How is that possible? Oh, if you see this, I have not imported Streamlit. I accidentally deleted it while deleting the commands relevant for the app that we developed in the previous session. So let's import Streamlit as st. Okay. Now this file, file1.csv, is there in Streamlit folder. I'll show this file1. This is there in Streamlit folder. There is a comma separated values file, a CSV file. Right? Now let's save it and come to app. You see that source file has changed. Let's rerun. The file is displayed. Right? Customer ID, everything is displayed here. Simple, right? And now we can create graphs. We can process this file. We can run algorithms on this data. Okay, many different kind of activities can be done. In this session, we are going to create graphs, a line chart and a pie chart and also a bar chart for the data that we read and displayed in our web app. See, our web app's functionalities and complexities are gradually increasing, right? The earlier session, we read a file and displayed it. Now we are going to use the data, create a graph and show the graph in our web app, right? So for that, I am going to use Plotly. Okay. So let's import first, import plotly.express as px. Then all you need to do is px.line will get us the line graph. We are defining the data frame. Okay. We are telling what will be there in x and y axis, right? And I'm creating 3 graphs. Since we have already run the app, we don't need to create the app again, right? So all I need to do is I need to save and then go to app. You see that source file changed. This is shown and I am going to rerun. Let's wait a moment for the graphs to appear. The graphs have now been displayed. We have a bar chart, pie chart, and a line graph. Okay. You can view this graph in full screen or in minimized option mode. Okay. You can download the files, right, as PNG. You can also zoom in, and Streamlit has given additional options also for us. Okay. So please explore them as you display graphs in our web app. Okay. In this session, I'm going to demonstrate how to display an external image. What I'm going to show in this session is how to show my company logo. If you see in web apps or any of the applications, the company or the individual who has created that particular application, that individual's or company's logo is normally displayed in the application, right? Now, if you see this particular file is in Streamlit folder, which is there in desktop. So this is the file that we are going to read and we are going to display the image that is there in this file. Okay. And I am going to add these 3 lines of code which we need for displaying the image below the lines of code that we used for the previous session. These lines of code were used for reading a CSV file, displaying the data and showing the charts, right? And these 3 lines of code, that is from PIL import image, then I am opening the image, image.open, then I am displaying the image. Okay. These 3 lines of code are needed for displaying the image and I have added them below the lines of code that we used for the previous session, which means our output, that is my company logo, will appear below the graphs. Okay. It is perfectly fine. Now all I need to do is I need to save and then refresh. Before that, let's see the code once again. I am opening image.open and then I give the path, right? And then I also mention the width. You can mention 200 or 300 depending on your requirements. Let's save the file. Okay, now come here and refresh. See this, the logo is already appearing. In fact, the graphs take a little while to appear and the logo is appearing here. Okay, as I mentioned, you can increase the size of the logo and you can change the position also. Okay. In this session, we will see how to create a button for uploading files. Okay. In AI applications, we have to upload files that will get processed and the result is displayed. The other option is to read a file that is stored in a particular folder. That's what we saw in the earlier sessions. Now we are going to see how to create a button using which I can upload the file for further processing. That's what we are going to see in this session. In fact, it is very easy to create. Let's delete the codes relevant for the earlier sessions. Okay, we have deleted them. All I am keeping is import Streamlit as ST and import pandas as PD. I just need a single line of code to create that button or a widget. Okay, uploader, file uploader is what we use, st.file_uploader. Let's save this and refresh. Okay, see that source file has changed. Rerun. See that you can use this particular option. You can browse the files and do further processing, right? As I said in the earlier session, we accessed a file that is stored in a folder. Now I am showing an additional option which we see in web apps, right? We upload files and then we do additional processing. Okay, in subsequent sessions I am going to show radio buttons, checkbox and other things that you will use in a web app. The other aspects that I want to highlight is here a mention of limit 200 MB per file is there. If you want to have a higher limit, you have to go for options where you need to pay money to Streamlit. Okay, we are accessing whatever Streamlit is providing to us free of charge. Okay, if you want to have files of higher sizes processed, you obviously have to go for paid options. Okay, and you see here upload a file is also mentioned and that particular icon is also there. Okay, in this session I'm going to show you how to create selection box, sliders and also submit button. You're trying to do 2 or 3 things here. First, of course, we start with importing Streamlit as ST, pandas as PD. Okay, if you see here, I want the users to select one of the 2 specializations, machine learning or deep learning, and basis that selection I want a message to be displayed. Your specialization is this specialization, that is one of machine learning or deep learning. In this I am asking the users to enter their name. Okay, st.text input. I am creating a submit button which is nothing but st.form_submit_button. Okay, I am creating a submit button using this particular command. Okay, and after that I am introducing another scenario. Here I am asking the users to select either development or business analysis as their role, and I am also introducing a slider to check their knowledge level on a scale of 0 to 10. If you see here, st.slider, st.select box, which is nothing but the selection box. In slider I can also have a minimum value and a maximum value here. Okay, and here also I have a submit button. I have one more scenario in which I am asking the users to select algorithm that they know and also self-assess on their knowledge level on a scale of 0 to 10. Okay, and I am giving a submit button also. Clear? So for creating selection box, it is st.select box. Submit button is submit_button. Okay, and slider is st.slider. And again you can have minimum value and maximum value here, right? Very simple. Now let's go run the code. Okay, before that let's save the file here. File is saved. Now I come to app and I refresh it. Source file is changed. I rerun. Okay, so I have this here, machine learning. let's say I choose deep learning. Your specialization is deep learning. Change it to machine learning. Your specialization is machine learning. I can enter any name here. Let me enter my name here, Govind. It's been submitted. And here I choose what is my role. Let's say business analysis. My knowledge level is, let's say, 8. Okay, I submit. See that the color changes. Okay, to indicate that the submit is successful. Here, let me choose random forest as the algorithm that I really like. On this, I have a knowledge of 9. So I'll submit. It says it's successful. You can also have some messages display. That is, the submissions have been successful. Okay, submissions for role and algorithm is successful, right? Depending on what users choose. That level of flexibility is available to us, right? As you saw in the code, very easy commands, right? All the requirements of having an AI based web app is fulfilled through Streamlit for us. Okay. In this session, we will see drop down option where single selection is possible and where multiple selection is also possible. I have taken the scenario of programming languages that one would be familiar with. In the first scenario that you have here, I am creating a select box where a single selection is possible. When it comes to multiple selections, I have to use st.multiselect. Okay. Here I am giving 5 options: Python, R, Java, C++, and Go. For those of you who are not familiar, Go is also a programming language that is gaining popularity and wide adoption. Okay. And basis the selection, as I said, here it is a single selection. We want the display to be programming language you are most familiar with is whatever language the user chooses. Here, because I have opted for multi-select, right, I can have more than one programming language that can be selected. Okay, and basis my selection, I want the output to say number of programming languages you know is number of programming languages. That is, it can be 1, 2, 3 as the case may be. Clear? Now let's save this file and refresh our app. Okay, we come here. In fact, I ran the code already, which is why you are seeing the output. Now let's rerun it again just to check if everything is in order. Okay, it's in order. The default option is appearing here. Okay, Python is the default option because that's what we mentioned as the first option, right? Let me choose say Java. Programming language you are most familiar with is Java. Okay, let's choose one more, R. Programming language you are most familiar with is R. Okay, the next one is which are the programming languages you know. As I said, this is multi-select, so I can choose multiple ones. Let's choose. So number of programming languages you know is 2. Let's select one more. See, it changes to 3. This is very helpful, right? Because we want our apps to be interactive also. It's not like somebody uploads the data and we see the results. Sometimes we want our apps to be interactive also. So options like these are really helpful. In this session, we will see how to change the themes. What you're seeing here is a light theme. Some people may like it, some people may not like it. Some people may prefer dark themes. Okay, Streamlit is providing us options to either have a light theme or a dark theme, or you can even customize the theme further. Okay, Let's see how to do it. What you're seeing here on your screen is a light theme. Okay. Now, how to change to a dark theme? You do that by going to settings first, and you see theme here. Let's choose dark. Okay. Now the theme has changed, right? Someone may come and say that, I don't like this black theme. Okay. I want a green theme, or a yellow theme, right? It depends on the requirements. If you ask whether such a possibility exists in Streamlit, it exists. You go again to settings, click edit active theme. See here, you can change the background color, right? The required code is also provided. Okay. Where you need to go and change for your customized theme to become effective, you need to go to the config file that belongs to Streamlit. How do you access this file? You need to first go to Anaconda folder, because we are doing all the coding in Anaconda, right? You go to Anaconda, and within that you go to Streamlit package, right, that you have installed, and within that you go and check for config file. Let me show that here. See this here, this is part of Anaconda. Okay, and within that Streamlit, I search for Streamlit. I got Streamlit, and the associated components, and within this, if you see, there is a config file. Okay, config.py file is there. You can edit this, right click, edit with notepad. So all this is there. Now let me do a Control F and search for theme. Okay, see this here. So it is here that you change the theme to your specific requirements. Say you want a yellow theme or a red theme. Okay, such a possibility exists in Streamlit. Okay. Before we see how to build the EDA app using Streamlit in Python, let's understand exploratory data analysis. Let's see what is this EDA and why we need to do EDA.
Before you develop artificial intelligence machine learning model, you are expected to do some data analysis. You are expected to check a few things. All these things are done to ensure a higher forecast accuracy. I am bringing this session based on my personal experience in doing exploratory data analysis and in trying to improve the forecast accuracy of machine learning models. I am confident that this session will be very useful to young learners and also to young professionals, because I have seen that young professionals have a tendency to jump straight into developing artificial intelligence machine learning models without doing this exploratory data analysis.
So EDA is about
how can you understand the data better, and what are the things you need to check as part of this exploratory data analysis. Multicollinearity is one of those checks.
In EDA, we start with understanding of the data.
In univariate analysis and bivariate analysis, how can you do this, right, as part of exploratory data analysis? If there are missing values, how are you going to handle it? Because in real life scenario, you are going to have missing values, right? That's part of life. So how are you going to handle? And you will have outliers too. In such a scenario, how are you going to manage the outliers, right? Do you need to transform the variables, or do you need to do something more? All of this we will be covering as part of EDA. Okay.
So now
we are going to see how to handle missing values. Missing values are very much a reality when we develop machine learning solutions. You have to handle missing values if you want to have a higher forecast accuracy. Sometimes the machine learning models may even throw up errors if there are missing values in your data set. Okay. And more fundamentally, missing values can lead to a biased model, right? You can make a wrong classification too if the extent of missing values is more, right? Why do we have missing values, in the first place? Can be because, values can be lost when you're extracting data from some other system, right? Or at the time of data collection, some values might not be collected. It can be due to an error also, right? There can be various reasons, but it's a reality. It's something that you cannot avoid, right? You will have some missing values, right? So how do we handle it? First strategy, delete the entire record. Second strategy, use the value of mean or median if that particular missing value should have a continuous data, right? If the missing value correspond to a categorical data, use mode, right? We have already seen that. What is mean, median, mode? Let's quickly see and come back, right? If you see this is something we saw in the previous session. Mode is the frequently occurring number, right? Median is the midpoint after arranging data in ascending order. Mean is the arithmetic average, right? So if you have missing values corresponding to a continuous data, you use either mean or median. If the missing data corresponds to a categorical type of data, use mode, right? That's all. Very simple, right? So in our data, in the insurance case study that we are looking at, we have 149 null values, right? I'm even checking null values according to different factors, right? Different variables. Now, why I'm checking it? Because my strategy will be different for different types of variables. If the variable is continuous, I replace with mean or median. If the variable is categorical, I replace with mode, right? Which is the highest frequency value, right? So now I am replacing, I have now got it. I am replacing with mean in the case of a continuous variable. In the case of a categorical variable, I am replacing with mode, as you can see the code here. And this takes care of the missing values because you are replacing with appropriate values. So now your data set is complete and you are ready to move forward, right? A very, very simple technique, but a very powerful technique in handling missing values, right? As I said, missing values must be addressed appropriately, either delete or replace with mean, median or mode, right? After replacing, check once if there are any missing values, right? Please ensure there are no missing values. Just to do the check, right? To be absolutely sure that there are no missing values, right? Run the code again and see if there are any missing values. As you can see in the case study that we have taken, we run the code again and there are no missing values and we are good to move ahead, right? Okay.
In this session, we are going to see EDA app, that is a web app to do exploratory data analysis activities. Okay, so let me first show you the data set that we are going to be using. We are going to be using a banking data set where factors like education, employment, income, loan tenure, loan amount, credit history, and similar factors are being considered. Okay. Unfortunately, the data contains null values. Okay. And there may be a relationship between the independent factors also. Okay. So we need to address these things before the data set can be taken for developing a machine learning model, right? So we are going to be doing EDA on this file or any other file using our app. Okay, so that's what we are going to see in this session. So let me take you through the codes that are relevant for the EDA activities. Okay, And I'm going to explain the codes using flowchart because it helps you to understand what is there in the code behind developing the app for EDA. Okay. Before we begin, we have to import the necessary libraries. Okay, we have to import Streamlit as ST, pandas as PD, plotly.express, that is for developing graphs, and of course NumPy as NP. Okay, so we need to do all these things before we begin. Okay, the importing of necessary libraries should be completed before we begin the actual coding. Okay, so the steps that are going to be involved are, we are going to start with title and markdown, right? So we have to give a name for this app, right, and provide additional details that we want to appear in the app. So that is the first step. So st.markdown, we are saying this app performs EDA. We are mentioning what are the libraries that are used, and I'm also providing, if you need any assistance, you can contact. Okay, so this is a spelling mistake, please pardon me for that. Okay, so you can contact, or you can give your contact details, and here I have given contact details of my company. Okay, so this is what we do in title and markdown, and then we go to uploading of the file. Okay, because I need to upload the file, right? So that is a single line of code. So here we use a file underscore uploader, and here we mention CSV and upload a file. These words are mentioned there. Please note that this app is developed for CSV files only. If you upload an Excel file, that is an XLS file, you are obviously going to encounter an error, right? Then we need to see if the file upload has been successful or not. If the file upload is successful, we need to read the file, right? So let's do that now, which is, we are checking if file underscore bytes is not none. Okay, file underscore bytes is the variable that we have declared for uploading of the file, right? And then we are asking reading of the file to be done. Okay, and that's what we are doing here. And after that, we are going to remove the null values and replace them with mean and mode. Okay, we are going to create a button to remove the null values, and we are going to replace the numeric values with mean and non-numeric values with mode. Okay, mean is nothing but arithmetic average, and mode is the frequently occurring number, right? So if you see here, we are creating a button, okay, and before that we are creating a header so that it is clear. To remove null values, please press the button. Okay, and we are also giving a label for the button, right? And then we are going to replace with mean in the case of numeric values and mode in the case of non-numeric values, right? And that's what we are doing here. If class is equal to object, right, we are going to replace that with mode, right? That means this is a non-numeric value. Clear? So we complete these activities in this step. And now for the next one. Okay, if the number of null values is 0, we want a message to be displayed. Okay, else we want to create and show a graph that basically tells the number of null values that are there in each of the different factors, right? That's what we are doing here. If you see this write, st.write is to display, okay, the number of values that are there, and we are going to be using plotly for the purpose of the graph. Clear? Okay. The next set of activities will involve creating a frequency chart, and then we are creating a histogram, and then we are going to see a correlation chart. Okay, so these are some of the activities that you can do in EDA. In fact, you can do more activities also. What I have shown is some of the basic activities that are done in EDA, right? Through this app, you are going to upload the file, and all these activities will be done with a click of a button, right? Now let's see this. We are creating a frequency chart. okay, in this using Plotly, and then we are creating a histogram. Okay, histogram is like a bar chart. You're going to see that now that I'm going to demonstrate it again using Plotly. The key point to note is we need to determine the number of bins, that is the range of the frequency, and how many bars should be there in the histogram should be pre-decided. Okay, if you're going to say use Excel to create a histogram, the number of bins is computed automatically by Excel. But since we are creating an app ourselves, we have to determine the number of bins, that is the number of bars that will appear in histogram need to be computed. So for this we are using this formula. Okay, other than that, the coding is very simple. We are going to display saying, you know, this is a bar chart. Okay, and then we are going to be showing the graph. Clear? Okay, the next step is correlation chart. Here we want to look at the relationship between two continuous variables, between two continuous independent variables. If there is a relationship between two independent variables, it can adversely impact our forecast accuracy. Ideally, we should not have a relationship between two independent variables, right? So for this, we are going to use px.scatter. This will show the extent of relationship that is there between two independent variables. We are going to plot that using Plotly, okay, and then we are going to say that, you know, this is a scatter plot for correlation, which we are displaying using st.write. Okay, so I have explained to you what is there in the coding for developing the app. Now let's go and run the app, see how the app looks. We will upload the data and we will check what is the kind of output we are getting in our app. Okay, so what you are seeing here is the complete set of codes that I explained using flowchart. In fact, I broke this set of codes into different steps and explained it using flowcharts, because when explaining using the codes written in a notepad file is not really user friendly. Okay, I have found that explaining using flowchart is helpful. Okay, we have already saved this file as edaapp.py. Now let's go and see this file in Streamlit folder. Where is that? EDA app is there, edaapp.py, and this is the EDA data that we are going to upload, and this is a CSV file. Okay, now let's run the app from the Anaconda command prompt. Okay, first change the directory, cd desktop, cd Streamlit. Now we are ready to run Streamlit run edaapp.py. Press enter, it will run. We will see the URL and it's going to open up in the default browser, right? See this here, the title, all the details that we typed are there. Need to contact, you can mention, and if you want you can put a image of your logo also, and this is where you upload the file. Let's upload, browse EDA data. Okay, let's wait for a second for the graphs to populate, right? So number of null values across different factors are mentioned, right? We have a total of 149 null values. So we can remove them. Okay, now let's say remove null, right? You can see here the total number of null values has become 0. Okay, and this is the bar plot to count the values based on a range. The bar plot to know the frequency of each category is mentioned here, right? I have chosen gender, that's what is the first one. We can choose married, right? How many people are married and how many are not married in our data set. right? We can choose, let's say, dependents. People with no dependents, applicants with one dependent, so on and so forth, right? The number of dependents, this is a simple bar plot. What you see below is actually a histogram. Remember, I mentioned we need to identify the number of bins. We calculated the number of bins programmatically. So this is based on a range, right? What you see here is based on applicant income. We can choose co-applicant income. See, can you see one more aspect? The chart above is for object variables, that is non-numeric, right? Can you see here? The chart above is for non-numeric, right? The chart below, that is this chart, is for numeric, integer or float variables, right? We have done all this programmatically. This histogram is for numeric variables, right? See here, applicant income, co-applicant income, loan amount, credit history, which is also a numeric variable, right? And finally, we will evaluate correlation, okay? Scatter plot for correlation, we need to select two variables and all of them are numeric. Please note that, okay? Scatter plot that studies the relationship between any two variables is only for numeric variables. Non-numeric variables, we need to use chi-square and other kind of tests, okay? What I'm demonstrating in this app is correlation, right? Which is why you see we have culled the fields relevant for numeric type of data. Now let's choose applicant income, co-applicant income, right? Can you see here? We will come down. See that scatter plot is there, okay? It is mostly a weak correlation, okay? R square will be about 0.5 or so. In fact, you can display R square also. That is also possible. R square that shows the extent of relationship between any two variables. As I mentioned earlier, EDA involves many activities. What I have shown here is a set of few activities that can be automated and displayed as a web app. Users can upload the data and do the set of activities, that is the EDA activities, to get the results instantly. Okay. Hello everyone. In this session, we are going to see how to create an app for predicting breast cancer. The data we are going to be using for this purpose is what you see on the screen. We are going to consider nearly 32 factors. I know the font size is small. I'm trying to fit all the factors in a single screen. So let me try to zoom in so you can see some of the factors and their values. Okay, we are going to consider radius mean, texture mean, perimeter mean, area mean, so on and so forth. These values correspond to the values of tumor that are observed in scan images. Okay, so whatever was observed in scan, it has been converted into measurable values like what you see on the screen. Okay, and we are going to be using logistic regression for the purpose of prediction. Okay, so let's get started with the codes that are applicable for the Streamlit app. Okay, the 0th step is in importing and installing the necessary modules. So we are going to import Streamlit as ST, Pandas as PD. We are going to be using logistic regression that we are going to import from sklearn. In addition to that, we are also going to import train test split, confusion matrix, F1 score, area under the curve, and also pre-processing. Okay, so we are going to import all of this, right? So this is the 0th step, and once we are done with this, we then move to the first step, which is we give a title and a markdown, right? We give title as breast cancer prediction, and we also mention this app performs breast cancer prediction. Some very basic details about the app is mentioned. We also mention the libraries that are used and what is the contact details. Okay. So once this is done, we then go to upload of the file. Okay. This is done using file underscore uploader. We also mention the type CSV file that needs to be used. After this, we check whether the file upload has been successful or not. Okay. And if it is successful, we read the file. Right. So that's what we are doing here. And the next step is in case there are non-numeric data in our data set. In fact, there are non-numeric data in our data set. We are going to convert them into numeric data through the process of what is known as encoding. Okay. All the data should be in numeric format only for the purpose of building the model. If there is non-numeric data in our data set, it will result in an error. So this is a mandatory step when it comes to building a machine learning model, right? So that's what we are doing here. And after that, we are going to select the dependent and independent variables. See, we have a list of variables, right? Remember, I mentioned there are 32 variables. So we have to define which variable is independent, which variable is dependent, right? So out of those 30 plus independent variables, we can choose say 15 or even 20, right? That option is there for the purpose of building the model, right? So that's what we are doing. If it is needed, we can select all the variables, or if you want to play around with the model, we can choose some of the variables also, of course based on certain conditions, right? It cannot be based on random thinking. Okay, so please keep this in mind. So we are basically selecting dependent and independent variables here, right? So the way we are doing it in Streamlit is once you have loaded the data, right, all the variables will appear. Okay, so you can remove them using remove. As you can see here, we can remove them. So that's how we are selecting dependent and independent variable. And after that, we are splitting the test versus train, where the testing is 25% and the training is 75%. And we mentioned random stat as 0 because we want randomness in picking data points. Once this is done, we predict using logistic regression, right? So that is the next step. So we will predict using logistic regression. So we first fit the model, right, for trained data, and after that we will predict, right? And once this is done, we will then create the confusion matrix for the test versus predicted, right? So we prepare the confusion matrix, so we know the extent of accuracy that is there. We also compute F1 and area under the curve. So this is also completed. Okay. Once this is done, the next step is to display accuracy and confusion matrix. We are predominantly using write command here, and we are displaying all that we computed in the previous step. Okay, right from confusion matrix, accuracy, F1 and area under the curve values. If you see the code here, the code relevant for building the model has been written within the code for building the app, right? So everything is in one set of code, right? For building the app and also for building the machine learning model. That is the beauty of developing a machine learning app using Streamlit. It makes the entire process so seamless and so easy, because we are not building a model outside the app, right, and calling it. Everything is within one set of codes, right? That is so much advantageous when it comes to debugging and maintenance of the codes. Okay. What you see on your screen is the code that I just explained. It is stored as a .py file. Okay, breast cancer app.py file. Now let's go into the folder, Streamlit folder, to see if this file is there. Yes, breast cancer app.py file is there. We also have the breast cancer data. So now let's go and run the code, run this app in Anaconda command prompt. Okay. Let's first change the directory here before running the code. Cd desktop, cd streamlit, then streamlit run breast cancer app.py. I've given enter. We will have the URL come up shortly and the app will open in the default browser. Okay. Since I'm running it afresh, it is taking a few seconds more. The URL has appeared. Let us upload the data here, breast cancer data. Okay. This is the file, CSV file. Let's click OK. As you can see here, the dependent and independent variables are appearing. What you're seeing here is the test and train data, right? The confusion matrix and the accuracy is also there. Now it has considered all the factors. See, you have an accuracy of 94.4%, right? The confusion matrix is there. If necessary, I can remove some of the variables from here. For example, I can remove radius mean. Okay, see, it is running again. It's become 93.7. Let me remove one more from the independent variables. It's running again. It remains the same, right? Let's remove another factor. See, it's become 95. So you can play around with these factors also, right? To see if the accuracy is improving or not. So that is the advantage. See, here we have built a wonderful app, right, where you are able to upload the values and you are seeing the results fairly quickly, right? And if you have a bigger file, more than 200 MB, you need to go for paid plans. What we have used, the version that we have used, is a free option, is a free tier. We don't need to pay anything for it. And even with that, we are getting very good speed, right? Very good processing speed, right? This is a cool app, right? You can define your dependent and independent variables and then run the model, right? So everything runs in the background and the user get to see the results, the confusion matrix and the accuracy. Clear? Very simple, right? In this session, we will see how to create a word cloud app. What is a word cloud? It is based on the concept of natural language processing. This is an example of a word cloud. If you have, let's say, a news article, we want to cull out the important words or the most frequently occurring words in that article. Okay, we can present the output in different types. Here I am showing it as if it is a thumbs up sign. Okay, and if you see, the word that is frequently used are company, product, message, installation, so on and so forth. We remove words like a, an, the, it, those kind of words are removed. Only those words that are important from the perspective of the objective of the article, only those words are taken, and we then do a count of those words and we present the words in the form of an image which is called as a word cloud, and the word with most number of occurrences in that article is shown in a bigger font. Okay, and the next most frequently occurring word is shown in a relatively smaller font. Okay, so this is how we present a word cloud, right? And that's what we are going to do. We are going to take about 2 or 3 articles and we are going to develop a word cloud for those articles. Okay, so that's what we are going to do in this session. Okay, I'm going to present the codes in the form of flowchart for your easy understanding. Okay. Our first step is to import the necessary libraries. Of course, Streamlit as ST, Pandas as PD, Matplotlib, this is for graphical representation. We are importing word cloud, right? We are also importing regular expressions, and the most important one is beautiful soup. Okay, this helps in natural language processing activities like the one that we are doing here. Okay, so let's get started with the actual set of codes. We have imported the necessary libraries. Our first step is to mention the title and markdown, right? We say that this app performs word cloud. We mention the Python libraries that are used, and the contact details are also mentioned here. Okay, so this is the first step, and the next one is we mention the link. Okay, here I am considering 5 links. These are blogs in the areas of artificial intelligence and machine learning. Okay, the next step is to select one of the 5 links, right? So for this I use select box and I'm going to choose the link. And after that, I would like to mention the number of words that I want in my word cloud, right? So I can mention this here. You can mention the number, right? This range is possible. Select the number of words you want to display, right? Here again I use selection box, right? And after that I'm going to create a word cloud. So for this, as I mentioned, I'm going to use a combination of 3 libraries. Okay, one is beautiful soup, right? The next one is regular expression, and the next one is stop words, right? As I mentioned, I will be removing words like a and the, it, those kind of words will be removed, and the count of words is taken for the remaining set of words, right? So that's what I am doing here. Okay, and the starting step is if the URL is not none, that means I have chosen something. If I have chosen something, then this set of codes will be processed, right? And then I am going to display, right? I am going to display the word cloud. So that's what I will be doing in this set of codes. Clear? This is the code that I just explained. I have already saved this as wordcloudapp.py. Okay. Now let us run this wordcloudapp.py in Anaconda command prompt. This is the Anaconda command prompt. Let's change the directory. cd streamlit, then streamlit, run word capital C. Let's ensure that we name this correctly, and now let's hit enter for this code to run. We're getting the URL and it opens up in our default browser. See here, we have the output. So this is the output because we have chosen just 10 words, and this is for this particular article. This is on predictive maintenance. The users can choose any one of the 5 articles, and they can also mention the number of words to be displayed, right? It can be 10, 20, and it can go on up to 100 also. Okay. If I choose, let's say 20 words, you can see the word cloud changing. See, it is running here. Can you see here? The number of words is increased, right? Now let's open another blog and see how it comes. It is changing. Can you see here? This is on healthcare. So healthcare, prediction, data, cancer, these are appearing as bigger fonts, right? Because these words have been used more number of times in the article, right? So here we have a wonderful NLP app that does word cloud, and it shows us the most frequently used word in the article. This is very simple, right? In this session, we will see how to develop a time series based forecasting app. Okay, that is a set of values that is dependent on time is fed into the app for processing, and we will have the future set of values. Example can be number of sales in a month done by a company. That is dependent on time, right? That is, in the month of January, certain number of sales happen. In the month of February, certain number of sales happen, so on and so forth. Let's say you have 5 years of data and you want to know what will be the future data points. That is, let's say if you have data from 2016 to 2021 and you want to know what will be the sales values for each of the month in 2022, this app can be used, okay, which is what I'm going to explain in this particular session. Okay, before seeing how to build the forecasting app, let's understand the forecasting process. In the table that you see on your screen, we have 5 data points corresponding to 5 months. So this is time-based data, and we can use time series forecasting to determine the values for the month of June and beyond. Obviously, the number of data points is fewer here. Algorithmic approach is helpful when data is complex and huge. As part of time series forecasting, we uncover 3 things: seasonality, trend, and residual. Trend is something that gets repeated over and over again. Festivals come during certain months every year, and sales could increase around that time, and this happens every year. So this is a repetitive phenomenon. While seasonality is long term, trend is short term. Okay, but both are cyclical events. These needs to be factored in our forecasting process. When you remove seasonality and trend from the data points, we get residuals. Forecasting is actually done for residuals, and we incorporate seasonality and trend into the forecasted values to arrive at the final set of forecasted numbers. For the purpose of forecasting the residuals, we use ARIMA, auto-regressive integrated moving average. The process of splitting the data into seasonality, trend, and residual, and subsequently forecasting of residuals, backfitting seasonality and trend into the forecasted values, all of this is done by an algorithm. Of many algorithms that are in the market today, I find Facebook's Profit algorithm to be much superior for time series forecasting due to very high forecast accuracy. So we will use this Profit algorithm in building the forecasting app. So as in the EDA app, I am going to explain the codes using flowchart because it is helpful to understand what is going on. Okay, flowchart is easier to understand and process. Okay, so now let's get started. What we do is we have to first import the necessary libraries. That is the first step that we do whenever we are developing any particular app. In fact, that's what we do in machine learning programming also. We import the necessary libraries, and then let's go into the codes now. Okay, so we have imported Streamlit, Pandas, Plotly, okay, that is for displaying the graph, and then FB Profit. Profit is a wonderful library. In fact, it is from Facebook, And in fact, it's one of the best libraries when it comes to time series based forecasting. In fact, we use that very extensively with our clients, and I regularly see very high forecasting accuracy with Facebook Prophet. If you have time series based forecasting needs, I strongly encourage you to use Prophet library. Okay, so now let's get into the codes. We start with title and markdown. That is, we want to mention what this app does. We also provide the contact details, and we provide the list of libraries, right? Or you can mention any other details also, right? And then we upload the file. Uploading the file, okay, file underscore bytes, that is the variable that I declare, and then I use file underscore uploader to upload the file. I clearly mention the type of file that is going to be uploaded, right? The next step is I have uploaded the file. I want to know whether the file has been uploaded or not. If it is uploaded, I want the file to be read for further processing, right? If the file underscore bytes, the variable that we declared, is not none, that means the file has been uploaded, right? We want the values to be displayed. Okay, now the file is uploaded, the processing has to start. But before that, I want to know number of days that I want the forecasting to be done, right? Do I want for 12 data points, 15 data points, 100 data points, right? Depending on your need. So you mention the number of days that you want the forecast to happen. It can be number of months, number of data points. It is for you to declare, right? So here we provide a sidebar and a selection box, right? st.sidebar.select box. You mention number of days, and I also provide a range. Okay, you can display the range also. It's entirely up to you. Okay, and I mention this, select the number of days you want to forecast. Okay, and then we forecast using Prophet. You're basically fitting the model. It's, as I said, it's a library, so it comes pre-trained. You don't need to train the model or the library here. It's ready to use. Okay, just 3-4 lines of code, the forecast is complete for us, right? And then we are going to plot the forecast. Clear? So this is the set of codes for developing the forecasting app. Now let's run the file, and I will show you how the app looks, how the forecasting is done. Okay. What you see here is the code for forecasting app. This I am showing to you in Notepad. The file has been saved also. Time series app.py is already saved. Let's come to the Streamlit folder to see if it is there. Time series app is also appearing here. Okay. Now let's run the code. Okay, in Anaconda command prompt. We will first change the directory cd.streamlit, cd streamlit, not cd.streamlit. Now Streamlit run. Ours is what? Time series app.py. We will run it. The URL will appear shortly. Okay, and the app appears in our default browser. So simple Streamlit app. Okay, time series forecast. You can give any kind of name. Okay, so I'm going to upload the file here. This is the file that I'm uploading. Okay. It's been uploaded now. You can see the name appearing. It indicates that the file has been uploaded, and I can choose the number of days you want to forecast. Is it 10? Right? What you see here, this is for 10. And Prophet library also provides the upper end of the range and lower end of the range when it comes to forecasting. Normally, when you forecast, it is normally within a range, right? We say that the value of 15 is expected and is likely to be in the range between, say, 13 and 17, right? Because forecasting is always in a range, right? Because forecast accuracy can never be 100%. Clear? Okay. I can also choose some other number of days also. See here, 127, 128. any kind of value within the range that we have defined in our program can be chosen, right? It's entirely up to us. So I'm choosing 120 days, and here are the set of values for 120 days. Clear? We can even structure the app in such a way that the values can be downloaded. Okay, we can change the way the values are presented. It's entirely up to us. Those kind of modifications are very much possible, right? We are going to see how to build apps for retail analytics. Before seeing the code, let's understand the concepts. CLV stands for Customer Lifetime Value. We're actually going to build an app to compute lifetime value of the customer. So let's understand this CLV concept now. CLV is nothing but the value we can derive from a customer over a certain time period. Let's say you are running a telecom company and you have many customers. Some customers will spend less and some customers will spend more. And this trend could change in future too. Using CLV, we can get a qualitative view of customers' worth over a certain time period. That is, we are predicting how much a particular customer would be spending with a service provider over a time period. It can be 3 years, it can be 5 years, 10 years, as the case may be. From historical data, we ascertain the average sales value and we use this data along with the number of transactions and time period to compute customer lifetime value. By time period, as I said, we are referring to any future time period, which can be 5 years, 10 years, as the case may be. We normally multiply by profit margin to ascertain how much net income we can get from different customers. Profit margin is nothing but revenue from customers less the cost that we incur to manage that customer or run the business. In CLV computation, we assume that the number of transactions is not dependent on their monetary value. The other thing to note in CLV is the concept of future value of money. In CLV, we are actually projecting the future earnings. What we earn in future is converted into present value terms using a factor known as the discount rate. That is, a $12 next year is equal to only $10 today, 20% being the discount rate, right? So please understand this. We will use time value of money in customer lifetime value because from the perspective of future earning, we are telling how much the customer is worth today, right? So we are essentially using time value of money in arriving at the value of CLV. Okay. So as part of CLV, we will compute recency, frequency, and monetary value. These are highly useful in segmenting customers. Recency refers to the time period when the customer made the last purchase. Frequency is how often the customer is making a sale interaction with the organization, and monetary value is the financial value of sales made by the customers. So as I said, we use this concept to segment customers and we can compute CLV for each of the customer segments, right? High value customer, medium value customer, low value customer, very low value customer, so on and so forth. We can compute what is the CLV. And so once we know this, we can run targeted campaigns, targeted promotions to increase the sale and derive more value from our customers. Having understood the concepts, let's go through the codes now. We are going to be using a package known as Lifetimes. It's a wonderful package to compute CLV. If you see, we also use gamma fitter as part of this package. This model, that is gamma fitter, assumes that the number of transactions is not dependent on the monetary value. So this is validated by the package itself. We also have few other utilities as part of the package which we import and install. Then we also have NumPy, Pandas and Plotly. Once we have installed, we create the title and markdown. We name the app and provide some basic details about the app here. We then create the file upload button using the file underscore uploader. We check if the file has been uploaded or not for further actions. We also indicate whether we want the results in a tabular format or a graphical format. Okay. The next step involves selecting the columns of interest, that is the columns that are relevant for computing the customer lifetime value. The next step involves model fitting. We indicate the observation end period here. Okay. Note the use of beta geofitter and gamma fitter. Beta geofitter, also called as BGNBD model, is used to find the frequency, recency and monetary value. This BGNBD stands for beta geometric negative binomial distribution. The BGNBD model is used to predict the number of orders, and the gamma model is used to predict their values. Gamma model also helps to incorporate the time value of money in computing the CLV. Gamma assumes that the monetary value will vary randomly around the average order value, and that the average order value varies across customers but doesn't usually vary much within customers and is independent of the transaction process. If you see the last two lines of code, we are predicting CLV for a certain time period, in this case 60, that is 60 months, and we are also assuming a discount rate of 1%. Discount rate, as I explained in the previous session, is used to convert future revenue from customers in present value terms. You can assume a different discount rate also. After we have completed all this, that is model fitting, the last step is basically displaying the data. We give the options to users. They can select either the tabular format or the graphical format. Okay. Now let's see the app in action. As always, we will run the app from Anaconda command prompt and the app opens up in default browser. So this is our app that we have developed in Streamlit, and we are going to upload the file here, and let's see the file once before starting the process. This is the file containing invoice number, stock code, description, quantity, invoice, invoice date, unit price, customer ID and country. Okay, this is from a retail scenario. As I said, CLV as a concept can be used in retail, e-commerce, telecom, banking, insurance and many other sectors. Okay, so here I have taken a retail scenario. Now let's come to the app and upload the file. We will choose the file, right? Let's choose it here. It is getting uploaded and you will see the results shortly. So we have the options available here, table or plot, and the table values have been populated. That is, for these customer IDs, what is the CLV value? Okay, Now let's choose the graphical format to see how the values are populated. It's essentially going to plot these, in the form of graph. That's all. Okay. So let's choose plot. It's running. Let's wait for a few moments. The CLV values have been plotted in the form of a graph. Okay. You can do many other things with CLV. We can segment customers, that is compute recency, frequency and value and show that in the form of a table. We can identify segments using those values, show the segments, how the segment is performing with respect to the customer lifetime value. Many other options are possible within the customer lifetime value concept. Okay. In this session, we are going to see the market basket analysis. First, we will see the concepts pertaining to market basket analysis, and then we will see the codes needed for building the app. Okay. This is also part of retail analytics, just like the customer lifetime value we saw earlier. When I say retail analytics, I am referring to retail as a sector. Okay. So market basket analysis involves identifying relationship between different items purchased by a customer. If a customer, let's say, bought coffee, will he or she buy ice cream too? Knowing this relationship is a wealth of knowledge for the retailers. When you are dealing with fewer items, you don't need algorithmic or programmatic approach to understand the relationship. When the number of items are more, we have to identify the relationship only through a program. So at its core, market basket analysis helps to understand the consumer behavior. It involves computing the affinity relationship of different items people buy in a retail store. Let's understand this with an example. When you buy a laptop, you may end up buying a mouse and a laptop bag also. What you see here is a classic case of frequently bought together items, also called as association. In the below, we are talking of recommendation. There is a subtle difference in the below because the customer could end up buying an item unrelated to laptop or computer too, like say a shirt or a pant. What we are interested in is finding whether such a pattern exists or not. We validate all of this through market basket analysis. Okay. As part of building the rules for market basket analysis, we look at three things: support, confidence, and lift. Support is about popularity of items. We understand how much a particular item is being bought. In confidence, we look at how many customers who bought X also bought Y. In lift, we study whether the sale increased when people bought two or more items together. If lift is more than one, it means there is a positive relationship. If it is less than one, it means it's a negative relationship. And when lift is 1, it means there is no relationship. Okay. Now, let's understand these three concepts using an example. In this scenario, customers have bought one or more of laptop, mouse, bag, and a headphone. Support for laptop, let's compute it now. It is actually 4 divided by 5. 5 is the number of sale instances, total number of sale instances in this example. Out of those 5 instances, laptop has been bought in 4. So support for laptop is 4 divided by 5, which is 0.8. Confidence is the probability that customers bought both together. Number of such instances, if you see in the table, is 2. So the confidence is 2 divided by total number of instances, which is 5. So 2 by 5 is 0.4. Lift is confidence divided by support. So we divide 0.8 by 0.4. This gives a result of 2, and 2 is obviously greater than 1. So that means the relationship is positive. Okay. So what I explained here, this kind of computation will be done programmatically through an algorithm known as a priori. Let's see this in action, and we are going to build an app for this. Okay. So this is the data set that we will be using as part of demonstrating market basket analysis app. This data set is about sale instances or sale transactions involving multiple items in a retail store. Okay. Now, coming to the app, there are broadly 6 steps. We first start with importing and installing the required libraries. We are using a priori to build the market basket rules of association, and we are also using word cloud and stopwords to display the results. The result will be, if a customer buys, say, coffee, what are the other products this particular customer is likely to buy? As you saw in the data set, there are many items to consider for building the association rules, and it cannot be done manually at all. We need an algorithm like a priori to make our life little easier, so that the planning manager can make use of this in the retail store. With association rules, the demand planning team in a retail scenario can take right buying decisions. Okay. So we have imported the required libraries. The next step is title and markdown. Here we give basic details about the app, the kind of libraries we are using, and the contact details. Okay. Next steps involve uploading the data set and checking if the data has been uploaded or not. We read the file, basically the columns and rows, for further processing. In this step, we are building the rules using the a priori algorithm. The algorithm computes lift, support, and confidence to determine the will buy item with respect to bought item. Okay. Here we are creating a sidebar for users to choose the items for which they want to see the will buy item. Basically, users will choose the bought items, and the result will show the will buy item or the expected to buy item. Right? Finally, we display the results using word cloud. Please note that you can display the results in the form of a table or even a simple text, or you can even have the results available as a downloadable file. Those are all additional options. Now we will go through the app to see how it looks. I ran this app from Anaconda command prompt. The program file is stored in the Streamlit folder. So let me rerun this. Okay, so this is the app. Let's upload the data file, market basket optimization, that is the file. And once I upload, you see the number of variables and other widgets are appearing. So you can choose either single or multiple item. Okay, and the first item is showing up as default. So in the case of brownies, okay, cottage cheese is the recommended item. You can choose more than one item also. See, you can choose multiple variables here. That option is also there. Let's wait for the drop down menu to appear, and we will be able to get the results for the recommended items. Select two variables from left drop down menu, right? Let's choose. We will choose tomato juice, and we will choose say pasta, right? Let's see what result we are getting. And as I indicated while explaining the codes, we are having the results in the form of a word cloud. Okay, the code is still running, and you can choose more number of words here as well, right? Instead of 10, you can choose 20, 30. That's purely up to you. Okay, now let's see what are the recommended items. The recommended items are fresh bread, shrimp, and escalope. Escalope is basically boneless meat. Okay, so with that, we complete this session on market basket analysis. In this session, we will see how to deploy the Streamlit app. Whatever we have seen so far, be it a word cloud app or breast cancer prediction app, we deployed it locally. That means we can see it only in our local browsers. It cannot be viewed on another computer or by someone else. We need to host it in a cloud platform like Heroku so that everyone can see it using a website address. That's what we are going to achieve in this session, right? So as I indicated, we are going to be using Heroku. That's a cloud platform for hosting applications. There are a series of 12 steps for completing this process of hosting the app. The first step in this 12-step process is downloading and installing Git and Heroku. Heroku is a cloud platform for hosting web applications, and Git is a place where we store all the programming and other related files. Okay, so let's first download and install Git if you have not done it. Okay, we download Git, and after that we download Heroku, right? We download Heroku and install it here, right? The next step is to create a Heroku account. Okay, you search for Heroku sign up in Google search bar, you will get the results, and you fill up all the relevant details and create an account. Once you have created an account, you open the terminal, right? That is the command prompt, and check whether Git and Heroku are installed or not, because sometimes the installation process may not be complete. Okay, and the way we do it is Git version. That's what we give. Okay, Git version 2.26.2.windows.1 is mentioned. That means the installation is complete. Now let's do the same for Heroku. Okay, we will check it. Heroku is also installed properly, right? The next step is the Streamlit app, which we have created. Okay, what I'm going to demonstrate is for the word cloud app, right? Whatever we develop for word cloud locally, we are going to deploy it in Heroku and access it using a browser in this system or any other system, right? So we will have a website address also. Okay, so we have this is something that we have created already. Okay, if you see this, I have proc file requirements set up, right? These three files should also be created, which is what we are going to do as next steps. The next step is requirements.txt file. If you see this, this is the notepad that we used for creating the app file, right? You can see here time series app.py, although it is a bit dull in color, right? EDA app.py, everything is there. Now I'm creating requirements.txt file. All that I mentioned here is what are the different libraries that I used, right? I mentioned the libraries one below the other, okay, and then save this file as requirements.txt. This is a text file. Okay, The next step is the proc file. Proc file, we mention this particular command, right? And then we save the proc file. Clear? The next step is setup.sh file. Okay, we mention these commands that we are there. Okay, we mention these commands and save this file as setup.sh. Clear? Setup.sh. We complete this also. So we have Streamlit, requirements, proc file and setup file. All the four are there in our folder. Okay. Now we open the terminal and log in Heroku. Okay. Heroku login. You see that Heroku, it mentions about an update. We don't need to worry about it. Okay. Only when we get an error, we can't proceed further. Warning is fine. Okay. It's about updating the version. So let's not worry about it. Press any key to open up to the browser. Okay. Once you enter, you get this screen. So all you need to do is click here and log in. Okay. Because you have entered before, it gets logged in automatically once you press the login button. Okay. Right. You can see here logged in as the email is also mentioned. Logged in is done. Right. So now 8 steps are completed. Now we go to the last 4 steps. So we have to create the new app in terminal, right? So Heroku create wordcloud-cport AI. This is going to form part of the website address, right? Wordcloud-cport AI. You can mention anything that you may like, right? So here I'm mentioning it as wordcloud-cport AI, right? We get the message here that wordcloud-cport AI has been completed. The creation process is done. Now let's log into the Heroku account and check if it has really happened or not. Okay, we then log in. Can you see here wordcloud-cport AI is already there. Okay, wordcloud-cport AI, the second in the list is what we created now. What you see above is something that we created earlier for the purpose of testing. Okay. The next step in the hosting process is initializing Git repository. Initializing means we are actually starting the project in Git. Okay. And the command we use is git init. If you see our folder, we only have these 4 files. Okay, app, proc file, requirements and setup. After we complete the git init, you will see that a git file has been created. Okay, rather a git folder has been created. Okay, we will now check the status of git using git status. We initialize the git repo and now we are checking the status of git. Let's see what we get. You see these 4 files are appearing in red, right? They are untracked. Proc file, the relevant app file, app.py, requirements.txt file and setup.sh file, right? So now we need to add them because they are untracked. We will do that using git add. In fact, we will give git add all. So all these files can be added. Okay. Once we give this git add all the files will be added. Okay. And we will check the status of git again to see what has happened to those 4 files. You see that 4 files are now appearing in green and they are waiting for the commit command. Okay. We need to commit the changes, right? So once we give git commit, these files will be added and the process of commit will be completed, right? Okay. And with this step, that is Heroku git remote, we are establishing the connection between Git and Heroku. Okay. The final step is about pushing all the files in Heroku master. Okay. We use git push Heroku master. Let's see what we get. The hosting has been completed and you can now see the external URL. Right? Now let's try to open the external URL and see whether we are able to see the word cloud app. Yes, we are able to see the word cloud app, right? Remember, this is the app that we created in our local system. Now it's been hosted in a cloud based platform, that is Heroku, and anyone with this link wordcloud-seaportai.herokuapp.com, anyone with this link will be able to use this app. This is very simple, right? We created the app, we hosted it in Heroku, and anyone can see the app now. In the earlier session, we saw how to deploy the Streamlit app in Heroku. In this session, we are going to see how to deploy the Streamlit app within the framework of Streamlit platform itself. Okay, so let's see how it is done. There are a series of about 4 or 5 steps. In fact, it is easier compared to hosting it in Heroku. Okay, only thing is the word Streamlit will appear in the URL. Okay, the first step is, of course, creating the account in Streamlit. You can use your email ID to create Streamlit. You can use your personal ID also to create an account. Okay, the next step is Git account, right? Creating an account in Git, you have already completed in the previous session itself, right? And we need 4 files. These 4 files we saw in the previous session also. App, that is the app.py, the file containing the code for the relevant app. Then we need proc file, requirements, and setup. So these are the 4 files. In fact, we moved these files into GitHub, right? All we need to do is, in our Streamlit account, we need to mention the URL, GitHub URL pertaining to where we have stored these 4 files, and we are done. Okay, app.py, the file containing the code, and then we need these 3 files: proc file, requirement, setup. This is something that we saw in the previous session itself, right? Now let's see how this works. This is the GitHub account where the 4 files are contained. Okay, so the 4 files are available in our GitHub repository. Okay, now let's go to Streamlit. Please create an account if you have not created one already. Okay, and once you have created, all you need to do is deploy the app now. Once you click new app, you will be taken to a page where you need to enter the GitHub repository URL details. Okay, since we have entered it already, it is showing the GitHub link. Okay, and once you click this, you will see the list of folders that are there in our GitHub repository. Okay, word-cloud is what we are trying to deploy now. Okay, the other things we had deployed it earlier. Okay, now we will choose this particular one because this is the one we are trying to host. Okay, now let's click that and then we click deploy. That's all. Okay, once you click that, you will get this image. Your app is in the oven. Wait for a few seconds and the process is complete. You will get this message, successfully installed. Okay, don't worry about this warning. This is actually for installing updates. Okay, so it's successfully installed and you can access the app using this link, right? Very simple, right? All you need to do is get hold of those 4 files: app, proc files, requirement, and set up, okay, store it in GitHub, come to Streamlit, create an account, give the URL link, okay, URL link containing these 4 files, right? Proc file, app, requirements, and setup, right? And then you click deploy. Job is done. Very simple, right? In fact, it's easier than deploying in Heroku. The only thing is the word Streamlit will appear in your URL. That's all. Hello everyone. In this session, we are going to learn about machine learning concepts. Okay, but before saying the machine learning concepts, let's understand what is AI. AI, if you really see, is a computer software that thinks and acts like human beings. Okay, it's a software, please note, it can reside inside a hardware entity. Okay, but it is essentially a software. It's a rapidly growing field, we all know that, right? And the impact is already there. Some of the examples that you can think of, it is already being used to predict diseases, okay, diseases like heart diseases, cancer diseases, proactive detection. That's what we are talking about. It's being used to detect and predict diseases even before it occurs. Okay, it is used to detect fraud, again proactively. It is used in recommendation system. What is this recommendation system? You watch a movie or listen to a song or watch a movie clip either in the Facebook or YouTube or in your OTT app. After a while, you realize that the app is making some suggestions to you, right? You can watch this, you will enjoy this song, right? So what is it? What is the suggestion based on? It is built on what is known as a recommendation system, and recommendation system is built using artificial intelligence, right? Face detection. Once upon a time, we used to mark attendance, by signing, and then we had access cards, then the fingerprint reader came, and now we have face detection serving as a means to mark attendance and also to prevent intrusion, for surveillance activities. We are using face detection, to open apps, right? So all this are applications of AI. So that's why I said AI is already here, and its impact is only going to increase in the months and years to come, right? So having seen what is AI, AI is a software, right? Let's understand the 2 different types of AI. One is called strong AI and the other is called weak AI. Strong AI, we are talking of systems that are thinking at the level of human beings, okay? That can think and act like human beings, right? What you see in movies, right? The fictional characters that you see in movies, right? They are all talking of strong AI. It is also called as artificial general intelligence and artificial super intelligence. But if you really see, we are not there yet. Okay, it's in the realm of research establishments. Okay, scientists are actually researching this. We are far away from a world where systems, artificial intelligence systems, can think and act like human beings. Okay, we are not there yet. So where are we today? We are in the realm of what is known as weak AI. But don't get fooled by the term weak AI. It is only to make a distinction between strong AI, right? The artificial super intelligence that we are calling the current level of artificial intelligence as weak AI, right? Even with the so-called weak AI, we are solving a lot of problems, right? But how are we doing it? We are solving problems by detecting patterns. Okay, we are going to see what is a pattern, and please note that this is the dominant mode of AI today. Okay, so which brings us to the question, what is a pattern? Right? A pattern is something that gets repeated in a recognizable way. Okay, in fact, I will go a step further and say that pattern is a consistent recurring characteristic. Right? It's a consistent but a recurring characteristic, right? So the system, the computer programming will identify something that gets repeated, right? And uncover the pattern, in your data, and through that it will solve the problem, right? That's how the world of AI is working today. And as I said earlier, this is the dominant mode of AI. Okay, so it is through these, weak AI systems, the so-called weak AI systems, that we are solving many problems, right? So that's why I said weak AI is a misnomer. Okay, don't get fooled by that. It's only in comparison to strong AI that we are categorizing the pattern recognition type of artificial intelligence as weak AI. Okay, it is only for comparing and contrasting, right? So now when you see this graph, right, what are the things you can note? Just take a moment. If you want, you can even pause for a while, right? Pause the video to see what are the patterns you can note in this graph, right? If you see, the peaks are occurring in the month of July. The troughs, the lowest points, are occurring in the month of January. The other pattern is the highest point in a calendar year, right, is progressively increasing, right, at a nearly the same rate. If you see the difference between this and this, it seems to be nearly at the same rate, right? And the pattern gets repeated every calendar year, right? So those are some of the patterns that we are able to uncover, right? And we are able to uncover even with our eyes, right? But what if the number of data points are more, right? If there are millions of data points, how will you uncover the pattern? That is why you need the software, right? That is what an AI system will do. Because in this, you are able to uncover the pattern even with your eyes, right? And you will say that for the next year, the highest point will be in July 16 and the lowest point will be in January 16. And the highest point will be somewhere close to 200,000. You can make such rough estimates, right? You don't need even a calculator for that. You can do that even with simple manual calculations, right? So we are able to uncover pattern, when through our eyes itself, just by observing. If the number of data points are fewer, if the number of data points are more, we need systems, right? That's what we are going to see, in the course of this program. Now let's see how AI is applied, in disease prediction, right? I mentioned this example earlier. The typical database that is used to build the pattern will consist of patient records with sugar, BP, heart disease, cholesterol, genetic predisposition, whether anyone in the family has had a heart disease or not, okay, and BMI, right, body mass index. So these details of people who have had heart attack and people who have not had heart attack will be there in our data set. So the system will uncover the pattern contributing to heart disease. Probably people who have a heart disease have a certain level of BP, certain level of sugar, certain level of cholesterol, so on and so forth. So it is those values, right, in combination is what is called as a pattern. So the system will uncover the pattern that is contributing to heart disease, okay? And whenever in future any such values of BP, sugar, cholesterol, BMI, genetic predisposition and such values are fed into the system will see if the pattern that it previously identified, right, as contributing to the heart disease, is it present in the current data set. If it is present, the system will say this individual is likely to develop a heart disease. If it is not there, the system will say the individual is not likely to develop heart disease. Please note that I am using the word likely, right? That is because we are talking of a probability, right? We are talking of a chance occurrence, because we can't be 100% sure, right, in prediction, because we are not God, right? We are still human beings who have developed the system, right? We are trying to play God, but we are not God, right? But so our accuracy is never 100%. So which is why we use the terminology likely to develop, right? So the same concept is what is applied in loan defaulter prediction also, right? Someone who is consistent in paying loan, will have a regular stream of income, probably supported by his significant others' income also, right? As a stable job, is in a thriving career, so on and so forth, right? Someone who is likely to default will exhibit the exact opposite, right? Probably experienced a layoff, right? Works in an industry which is in a downfall, right? So on and so forth. So the algorithm, the computer program will try to uncover the pattern, right, that is contributing to a lone defaulter. Once the pattern is identified, when I say pattern, it will create, the set of values that taken together leads to a scenario of a lone defaulter, right? So once that pattern is detected, it will check whether the same set of values or the same characteristic is there in the current data set also. Once it is there, it will say that this individual is likely to default, right? So this is how the world of AI works, right? It tries to uncover the pattern. Okay, from the given data set, it tries to uncover the pattern and applies it for future, right? I hope you understand now how the world of AI works, right? So having seen examples, having seen how AI works, let's see some more aspects related to AI. What you see, in headlines, in media, is it's all about AI, right? But if you see in this course itself, we are trying to learn about machine learning. So what is AI and what is machine learning, right? If you really see, AI is the headliner, right? That's what is flashed, in the media. But the technology that is driving AI is actually machine learning, right? So all the pattern recognition that I talk about, the core underlying, science is machine learning. And whenever we talk of machine learning and artificial intelligence, you will also hear about another technology called as deep learning. Deep learning, is an advanced form of machine learning, can be thought of as a subset of machine learning, right? I hope you understand this. Now let's understand machine learning in more detail using an example. Okay, so I am inputting 3 apples, the red colored apples with a green leaf. Okay, it's in this particular shape. I'm giving 3 images and I am referring to these 3 images as apples. Okay, I am helping the computer system to understand that an object, if it looks like this, it is known as an apple. Okay, so the model has been developed, okay, in such a way that if any object is inputted, it will check whether these characteristics are displayed or not. Okay, if the characteristics are displayed, it will say it is an apple, right? The characteristics are not displayed, what will it say? Can you think of that? It will say it is not an apple. Okay, why does it say it's not an apple? Because all that the system knows is, if these characteristics are there, the red colored with a green leaf, right, this particular shape, if these characteristics are there, it is known as an apple. If these characteristics are not there, it is not an apple, right? What if I feed this particular apple? Okay, if I feed this particular apple, what will the system say? It will still say it is not an apple. Why? Because in this, the color is different, right? This is pinkish apple, pink colored apple, whereas this is a dark red apple, right? Wine red. Okay, now let's see one more example. If I feed this image of the apple, what will the system say? Will it say it's an apple or not an apple? Think. It will say it is not an apple. Why? Because the leaf, right, the protrusion of leaf is on the right, but here if you see, the protrusion of the leaf is on the left, right? We are human beings, right? We know that the protrusion can be on the right or left, right, or both sides. The system doesn't know. The system knows based on what you have fed. What we have fed is a dark colored apple with this particular shape and with a protrusion of leaf on the left side. Those are the characteristics that we have fed and we have labeled them as apples. But here the leaf is protruding on the right, so the system will say that it is not an apple. right? Because the characteristic of protrusion of leaf, is on the right and not on the left, right? What if I feed an orange? It will say it's not an apple, right? So this is known as what is called as supervised learning. That is, a reference is provided. If an object were to look like this, I'm giving the reference, okay, or I'm giving a label known as apples, okay. If those references or annotations or labels are not there, the system will try to group similar type of objects based on the characteristics. If you see, I have fed images of apples, the bright red colored, the pink colored, and the bananas, right? So the system has grouped the red colored apples together, the pink colored apples are grouped together, and bananas are grouped together. So this type of machine learning is known as unsupervised learning because the references or labels are not there. If you see the models that are used today, majority of the models are in the realm of supervised learning only, okay. The example that we saw, disease prediction and loan defaulter prediction, would come under the area of supervised learning only, okay. Then why do we have unsupervised learning? Unsupervised learning is used in the area of segmenting customers, right? Normal way of segmenting customers is based on one or two dimensions, right? Based on the revenue the customer generates, or based on the type of the customer. The customer is a large customer, small and medium business customer, or an individual retail customer, right? So those are known things. But what AI systems can do is uncover new segments, and that's wealth of information for any organization, right? So supervised and unsupervised learning are what are used extensively as of today, right? And even between the two, supervised learning is what is used more, right, than unsupervised learning, because unsupervised learning is primarily used when references are not there, right? The third type of reinforcement, the third type of machine learning that is also applied but not as widely used as supervised learning is reinforcement learning. Here, the system learns from mistakes and responses, right? If you feed an apple, okay, it will probably say a mango, right? Then you say, no, it's not a mango, it's an apple, right? System notes it, right? And this kind of cycle goes on and on, probably, tens and thousands of cycles, okay? The system learns and then it correctly says that it is an apple, right? So this is known as reinforcement learning. As I said, this is not as widely used, okay? So the one that is widely used is supervised learning. Unsupervised learning, as I said, is used primarily, in the world of customer segmentation. What is the other benefit of unsupervised learning? It is also used to detect outliers, fraud detection. Unsupervised learning is used, right? The biggest advantage with unsupervised learning is you don't need these references or annotations or labels, okay? Right. So, having seen what is AI, what is machine learning, what are the different types of machine learning, okay, let's understand with an example in more detail, okay. So, in this, I am trying to predict what is going to be the future marks a student will score, right? So, what are the parameters that I can consider, right? Number of hours study, whether the student goes to school or college on time, whether the student is attentive, whether the student asks questions, whether he or she participates, right? Whether he or she takes notes well, right? These are the factors I am considering. So, and I am trying to predict what will be the future marks, right? This is what is contained in my historical data, right? This is what is contained in my historical data along with the marks obtained, right? Because here we are referring about supervised learning, right? Some kind of reference is there. In the apple example, we said that if certain characteristics are displayed, right, it is an apple, right? Here, if certain characteristics are displayed, the student is likely to score more marks, right? So it is a kind of supervised learning. But the key point to note is here we are actually trying to predict the number of marks, right? So I need inputs for all these characteristics, and I also need, when the student displayed these characteristics, how much marks he or she obtained, right? That is part of my historical data. It is with that data that I identify the characteristics and hence the pattern, right? And in future, for any student, if I feed the values corresponding to these characteristics, I can then tell how many marks he or she is likely to get, right? So please note, in my historical data, I had values for these characteristics, these parameters, and I also had what was the corresponding marks that the student got, right? So the system is able to uncover the patterns and, okay, help us to determine how much a student will score in future, right? It is like, I can predict like 88.2 out of 100, right? That is the way we operate, right? Okay. So let's also note this important distinction, right? Machine learning differs from traditional programming. In traditional programming, we give input, data, program is there, it gets processed. 2 plus 3, if you input and you want the system to add, it gets processed and you have the output as 5. 2 plus 3 is 5. That is traditional programming. In machine learning, you saw we are actually passing some references for output, right? What are known as labels, right? Annotations. So the kind of output we want is passed on as references or labels, right? So what is really an output in a machine learning program? The real output in a machine learning program is the pattern. The system finalizing the pattern is the core output in a machine learning, right? Because the kind of output we want, we are actually passing in along with our input data in the form of references or labels. That doesn't happen in traditional programming, right? So please note this key distinction between traditional programming and machine learning. This is a very, very important distinction, right? Another distinction is machine learning is actually at the intersection of computer science and math and statistics, right? Because in traditional software programming, all you need is domain knowledge, right? And computer programming knowledge. In machine learning, you need the concept of math and statistics. Why it is important? Because the characteristics of patterns are represented in the form of numbers. So to understand those numbers, you need math and statistics, right? So machine learning is actually at the intersection of computer science and math and statistics, right? So this is something that we saw earlier. Machine learning, the 3 types of machine learning: supervised, unsupervised, and reinforcement, right? There's one more way in which you can classify or categorize machine learning. What is called as classification type of machine learning or regression type of machine learning. We also call it as classification algorithm or regression algorithm. Let's understand this with an example, right? In the case of regression, we are telling what is the temperature going to be, right? It's going to be 84 degrees Fahrenheit. If I say whether it will be hot or cold based on the temperature, right? Based on the temperature for tomorrow, then I am talking of classification. If you were to extrapolate this to the student example, if I tell how many marks the student is going to get, okay, then I am talking of regression. If I say whether the student will score high marks or low marks or medium range marks, then I am talking of classification, right? So let's understand the different types of machine learning because we will be using them in real life, right? So if you see and relate it back to supervised and unsupervised, this classification regression comes primarily in supervised learning because it works based on references. In unsupervised learning, all we are doing is segmentation or clustering or grouping, right? So this is the difference between supervised learning, unsupervised learning, and where classification and regression fits in, right? Another key concept that you need to understand is test data, train data. Remember in the student example, I said we will be collecting data pertaining to different characteristics. Along with that, we will also obtain the number of marks for those values of characteristics, right? Once we have the historical data, we will split the data into trained data and test data. Okay, the actual developing of the model happens on what is known as trained data, because I want to doubly sure, I want to make sure that whatever pattern I have uncovered is actually true, right? Is actually holding true. So whatever model or whatever pattern that's been uncovered in the training data will be applied on the test data, right, to check for the accuracy. If the accuracy is good, I will then take it to future or current data, right? Why I split it? Because I want to be doubly sure. I want to ensure that my accuracy level is high. Remember, we talked of disease prediction. If you say that someone is likely to develop a heart disease, you better be 99% accurate, because you don't want mistakes there, right? Because it's a question of life and death, right? So even in historical data, I split the data into test data and trained data. Okay, and I develop or uncover the pattern in trained data. Whatever pattern I've uncovered, I go and validate in test data, right? Because the value is there, so I can compare and check what is my accuracy level. Once I am satisfied that my accuracy is high, I will go and apply the pattern on the future or current data. So that's how the world of machine learning and AI works. Why? Right? What if the accuracy is not good? We will do many modifications. We will check the data, right? That's a separate topic in itself, right? Okay. So the typical ratio in which the train and test data is split is 80-20, 90-10, 2/3, 1/3. You know, these are judgments, right? These come with experiences. You play around with the ratio because our objective is to have a higher forecast accuracy. And this completes the session on machine learning concepts.
Hello everyone. So we will do a quick summary of simple linear regression and multiple linear regression, and then get into logistic regression. So that's what we are going to see in this session. So just to recap once again, machine learning, it is about making the software identify the patterns that is inherent in our data. Again, to refresh, pattern is a repeatable characteristic, right? And some of them are easily identifiable, some of them are difficult to identify, but they are identifiable. So pattern is an identifiable, repeatable characteristic. So we are trying to identify the patterns in our data set, right? So the software learns this process of identifying patterns. How it does? By studying the historical data. Okay. To be specific, what is called as the training data. If you see, we start with the historical data where the output and the input variables are given. So if we take the example of whether someone will get a heart disease, that is an output, right? Factors like age, weight, sugar value, cholesterol value, BP, ECG values, all these are input variables. So historical data contains these input variables and whether that particular person got a heart disease or not, right? So from the historical data, I split this into what is called as trained data. So it is using this training data that I am developing the machine learning model, right? So once this is typically, it can anywhere from the historical data, it can be 2/3, right? Or it can be 75% or even 80%, right? So the remaining is to validate whatever you have trained. So using the training data, we are developing a model, right? And once you have developed the model, we validate that using test data, because in test data, I will have both the output as well as the inputs, right? And once the model is validated, right, you then apply it for current or future data. So this is how it progresses, right? So this is the process of splitting the data and developing an ML model. So train versus test, as I said, it can anywhere be, training can be 90%, 80%, or 2/3. So it's a trial and error that we use to ensure we get a higher forecast accuracy, right? So this is the linear regression. Again, to refresh your memory, we did number of hours studied and marks uptake, right? So we created what is known as a scatter plot, right? This one is the scatter plot, and once I click it, I get the options, right? I click the trend line. The trend line comes, we are choosing the linear, so we get this equation. I also ask for displaying the equation on chart, right? So y equals mx plus c, right? 10.862x plus 41.901. So that is the equation I'm getting, right? So marks obtained is 10.862 into number of hours studied plus this number 41.901, right? Marks is the dependent variable, or what is called as y, and number of hours studied is the independent variable, or what is called as x. Okay, so this slope, right, this y equals mx plus c. M is the gradient, what is called as the slope, 4 divided by 2, and c is the intercept. This is where the line meets the y-axis. Okay. We have seen this. So how do we create this programmatically? By using the scatter plot, right? We are first creating. So this is an array that we have. I'm using the scatter, and once you get it, I use scientific Python here. That is a package that is already available. Here I'm not doing any split of test versus train. In the next example, we will see that, right? So I am defining a function. I'm computing slope into hours plus intercept, right? And this function runs for each of the values of number of hours studied, and I'm plotting the values using matplotlib, right? So that's what I'm doing. And after that, I'm also computing what is the R, and I'm trying to find the value for one of the numbers, right? That is for 3.25 hours studied, what is the marks update? This is clear to everyone, right? Any questions? So I presume there aren't any questions, right? So moving on, now we will see how we did using the test versus train concept, right? So we are importing the data, right? So for this, I'm mounting using drive.mount. I'm accessing it. This is something we have seen before. So once I give this on drive, I give this command content drive. It prompts you to go to this URL. Once you go there, you sign, right? Once you have signed, you allow access, Google to access all this, right? Your files, right? After this, it will give you a password. You click it, you enter it, and the drive is mounted. You can access it. Any questions on this? Are we clear? Are we absolutely clear about it? Okay. So once you have done this, here I'm splitting. Test I am taking is 1/3. The training is 2/3 data, right? So the same marks obtained based on the number of hours. I have more data points. I have this as a comma separated value, CSV file. That is like an Excel file, right? So here I'm using, I'm defining what is X and Y, right? Basically calling out the columns. And I'm using scikit-learn or sklearn. That's one of the predefined libraries. I'm importing the test train, split. Okay. And then I go into fitting the model, right? And I also compute what is my R square value for both the scenarios. So that's all I am doing. Clear? Any questions on this? So as you can see, the value is only about 80%, right? We hope, by increasing the data size, we can expect a higher test result. So this is the data we accessed, right? So that is clear to all of you. Linear regression. No questions, right? So multiple regression, if you see this, we did what? Y equals mx plus c, we are writing it as b0 plus b1. In the case of linear regression, it is b1 x1, b2 x2, bn or bp xp, plus there is an error component, right? That is applicable in both the scenarios, right? So here there is a single variable, here you have multiple variables. So the same mounting that we do, right? Once you have done this, we took the example of carbon dioxide emission. X1, X2 is vehicle volume, vehicle weight. And instead of the actual amount of emission, if I go for likelihood of carbon dioxide emission, I am talking of what is called as logistic regression, right? Instead of multiple linear regression. Okay, so this is the file that I have. My X is weight and volume and Y is carbon dioxide. So from sklearn, I'm importing the linear model, right? I am fitting this, right? And I'm also trying to predict what is the value here. Okay. I can also do the same and compute the using test train, because in this, if you see, I have not really done a test train. I have straight away gone for fitting. But here I can do a test train also, right? Here I have taken training is 80%, test is 20%. Right? The other example we saw is I have multiple factors, right? I'm trying to find what will be the insurance charges given I have multiple factors here, right? So the first thing we saw is we need to identify what is the data type, right? Is it an integer, float, or is it nominal and all those, okay? That is the first thing we need to check. After that, we have to split this into two, right? That is all the values, integer and float related is one. The other is the nominal related, this is the other set. We are splitting this into two, right? And through the process of encoding, we are converting this into numbers, right? Through the process of encoding, we are converting into numbers. And after that, we merge the two. We split it and now we are going to merge the two, or we concatenate. In fact, that's the term we use. And after that, we go for developing the model like we saw before, right? So what is the first step? I'm mounted, I'm reading it, right? I'm using the head of 5, I'm seeing what are the top 5. And after that, I am splitting, right? Data 1 and data 2. Data 2 contains all the nominal values. Data 1 contains all the numerical values, right? Basically integer and float. Data 2 contains all the nominal values. So I'm splitting this, right? And after that, I use the same sklearn for take it through the process of encoding. I'm converting all the nominal into numbers. The same process we will repeat in logistic also. Please remember that is one of the requirements, because we are trying to understand the characteristics of patterns, and characteristics of patterns have to be in the form of numbers, right? So, and after this, once we have converted into numbers, I concatenate data 1 and data 2 along columns, axis 1, right? I have now added. I am now defining what is my x's and what is my y, right? Y is my charges, X is anything other than charges in this data frame. So once I have done, I am now going to develop the model similar to what we have done before in linear regression. The concept, the model thing, the code is nearly the same, right? If you see this, first is train test split, and then you are fitting the model, and then you are computing the error value. In this case, I have taken test is 25%, 1/4. So training is 3/4 or 75%. Right? And then I'm fitting and I am predicting also for one of the values. Right? If you see this, in addition to R square, I've also computed root mean square error. That is the absolute difference between actual and predicted. Sometimes it is good to see both, okay, to get an idea of what is the error value. Got it? Any questions so far? I will just pause for a moment. Any questions? So what are the things we saw? We saw the concept of test versus train. We saw the concept of linear regression, that is y equals mx plus c. We also saw, how you can develop it in Excel itself, and then using Python, we tried to create, the line of best fit, and then using the concept of train versus test split, we developed, a linear regression model. So, and subsequently, we saw, if there are more than one factors, how will you predict? Right? What is known as multiple linear regression. Right? The concept is the same, but the key thing that you need to notice, whenever you have a non-numeric value, that is when it is not integer or float, right? If it is like a nominal or ordinal, right? You have to convert those non-numeric values into numeric values using the process of encoding. And that encoding function comes as a predefined library from sklearn. And after that, the process of developing the model is the same. You have to define X and Y. Then you have to fit the model. Then you have to define the train versus test split. Then you go for fitting the model. And once you have fitted the model, you look at what is the R square value for train and test data. If you want to predict any values, you then use that model to predict any future values. So what is the need for a logistic regression? Right? For example, if I'm going to predict based on the size of the tumor, whether the tumor is cancerous, which is what malignancy is all about. Malignancy means whether, cancerous, whether the tumor is cancerous or not, right? If I'm going to draw a linear regression, okay, remember the concept is still the line of best fit, okay, I won't be able to draw a line that will meet everything, right? For example, for a line, for a point that I have to take care of this, it will go out of the range, right? I cannot meaningfully draw a line that will take into account all the points, right? So I have to necessarily go for what is known as an S-curve, okay, which is nothing but a logic function, right? A logarithmic function, okay, or exponential. What is log? It is nothing but exponential, right? Exponential e to the power something, e to the power -2, something like that, okay? So log, okay? So because this kind of function can explain, right, the kind of data that we have here, right? So whenever we have yes no kind of scenario, one of the options for us is to pursue a logistic regression, okay? In fact, logistic regression, in fact, people will say that I want to use very high-end tools, very sophisticated tools. What I have found is logistic regression addresses most of the problems in the world of AI and ML. Okay, first class algorithm, right? It can address most of the problems. Okay, in fact, normally, in real life scenario, what we will do is we will try to compare multiple models. Okay, we will use the same thing. We will use a logistic regression. In the next future, we are going to see decision tree. Okay, or we see random forest. In all those scenarios, we will compare. The progression is not that high. Okay, in terms of accuracy. Okay. So logistic regression is a wonderful one. And remember, we use the word regression. Okay. It is not really a regression. It comes under what is called GLM, generalized linear models. Okay, because it is not strictly a linear one. Okay, it's a generalized linear, which means basically we are talking of yes, no, binary. Right? Good, bad. Right? That's what we are talking here. Go, no go. Those kind of things what we cover here in logistic regression. Right? So what is the model here? If it is a straight line, we are talking of B0 plus B1x, nothing but MX plus C. Okay. Just here I've used the term B1 and B0. Okay. It's nothing but y equals mx plus c. In the case of a logistic model, this is a sigmoid function. The formula that we will use is 1 plus e to the power minus b naught plus b1x. This is nothing but log. Okay. This is nothing but log. Okay. And we are trying to find p-value, which is probability. What is the probability that something will be good? What is the probability that a particular team will win? What is the probability that an individual will not do well? Okay, so that's what we are going to be thinking here, right? So what is the difference between a linear and a logistic regression? Here it is used to predict a continuous variable, right? Continuous variable, a number like 41.2, right? Here you're talking of logistic regression, categorical, yes, no, that we saw. It is used for solving a regression problem. Here it is used for solving classification problem. Though we use the word regression, it is strictly not regression. That's why I said it comes under generalized linear model, GLM. Okay. Then here we are trying to find the best fit line. We find the S curve. Okay. Here we use R square. Here we use area under the curve. Right? Remember the type 1 and type 2 error? Do you remember that? What is type 1 and type 2 error? So type 1 and type 2 error, remember this applies in logistic regression, right? Let's say you are trying to predict whether a person is likely to be cancerous, is having brain cancer or not, right? For predicting, if you predict someone wrongly, when he is not having anything, right? Or when he is having, but you say that he is all right, right? Those are the examples of type 1 and type 2 error. Because here we are going to look at area under the curve. Accuracy is what? True positive and true negative. Where I have predicted correctly, divided by all 4. Clear? If it is closer to 1, it means it is a good prediction. Can you see here? The overlap is very less. This corresponds to true positive, false positive and false negative. Here the overlap is more, right? the area under the curve comes down. Clear? So now let's understand the math behind it. In fact, I'm not even going into too deep a math. Okay. Now, if we see that, for example, but certain element of basic mathematics is essential. Should someone get insurance or not? Right? And what are the factors? Age, sex, BMI, region, etc. Because the output has to be between 0 and 1. What will be this? This will be a value, this p value. Probability is always between 0 and 1, right? Correct?
Yeah.
Probability is always between 0 and 1. So I must convert all of this into a value between 0 and 1. My output is going to be between 0 and 1. Hence, my x's should also be between 0 and 1, which means that I must transform or convert all my x's into values between 0 and 1. For this, we use this formula. Okay. So, how will you compute B0 and B1? That's what I'm going to explain to you. Right. So, now, what I am doing, if you really see, I'm actually trying to in mathematics, pure mathematics, if I call, I'm trying to optimize this whole thing. Okay, it's an optimization problem, actually speaking. What is an optimization problem? I am trying to reduce the extent of false positive and false negative. Okay. Again, strictly, if I were to use a mathematical term, this false positive and false negative are called as losses. Okay. Loss, right, to the whole machine learning exercise. So I am trying to optimize the losses, right? I'm trying to optimize that is basically I'm trying to reduce the false positive and false negative. Okay. So if I were to use the pure mathematical terminology, I am trying to optimize a loss function. Okay. So for that, as I said, first I will convert, then I'm trying to minimize. All of machine learning is an optimization exercise. Optimization to reduce the extent of false positive and false negative so that my accuracy is always higher. Okay. Now, what I am trying to do here, I am trying to find the weightages. Okay. What are these weights? For example, let's say I'm going out and trying to buy a shirt. Okay. So what are the factors I will consider when buying a shirt? Can anyone tell? What
material, size.
Right? Size, material, color, fitment, design, price. Right? I have 6 factors. Right? These factors are there in your mind. Right? You may not probably realize it. Right? So when you go into the shop, right, maybe that particular shop, for the particular salesman or saleswoman is showing you some shirts, right? Or you yourself, you are looking at the shirts, right? What are you doing actually? You are evaluating the shirt on those 6 parameters. Yes or no? Would you agree with that statement?
Yeah.
It's just that we are not aware, right? I mean, we intuitively, it comes so naturally to us. Okay? It comes so naturally to us, we will evaluate, right? What are we doing? We have given certain weightages, right? Price, let's say, is, let me take fewer factors, okay? For me, fit. Then design, then material, then price. Let's assume these are the four price and let's say color. These are the 5 factors that I consider. In my opinion, maybe this is 40%, this is 15%, material is another 15%, that's my 70. Fit is important for me and design is just 5%. This is for me. Okay. For someone else, you will have a different set of weights. Right? How have you arrived at this weight? It is over so many experiences, right? I have arrived at this weight after so many experiences, right? I am at this stage in life and I have gone through so many experiences. Maybe this will change in future also, right? This will change in future also because your taste can change, right? For now, this is your preference, right? So you evaluate your shirt and then you finally say that, yes, I'm going to pick this particular shirt because it comes very close to this fitment, this weightages. That's exactly what your logistic regression is also doing. It already has got some base data, right? So trained data is there. In that, output is also known, right? The factors are also known, right? It keeps on giving different weights, okay, and identifies the optimal set of weights, okay, optimal set of weights that will minimize the loss of the error. Is this clear? That's all the logistic regression is doing, right? Because logistic regression knows, right? In the training data, it has these different values and whether insurance was given or not. That data is available, right? The training data. So it will keep playing with different weights, finally arrive at and compute the accuracy, right? It keeps on checking whether it's right or not. It does this exercise in an iterative manner, right? Goes through many iterations, okay? And that is decided by the algorithm, right? You don't need to worry about the number of iterations and all that, okay? Normally it is 1 or 2, okay? You go for multiple higher models, this can happen over 15, 20 and all that also, okay? Multiple iterations and then this is predicted. Clear? Any questions on this?
Sir, can you repeat it again?
Yeah, sure. So just like how you are choosing a shirt, on different factors, right? You're doing it intuitively. You have arrived at these weightages after so many iterations, right? Sometimes you have bought a shirt that you have not liked subsequently also, right? You have gone through all those experiences and hence arrived at these weightages. So all that the model will do is it will go in an iterative manner and identify the optimal set of weightages. This weightage that I have for dresses, the algorithm will identify the weights for these factors. That's all it is actually doing. Because once the optimal set of weights are identified, okay, that corresponds to a higher level of accuracy, which means that instances of false positive and false negative are fewer, my problem is solved. Clear?
Yeah.
Okay, so let me just remove this. Right, so what it does, it is trying to minimize the loss. This process is known as gradient descent. Okay, it is trying to minimize the loss. Loss is nothing but extent of false positive and false negative. That's all it is doing. Okay, this is process is called as back propagation. Okay, this is known as input layer. You get to see the output. This entire thing happens in what is known as a hidden layer. Okay, hidden from the output. No, nothing sinister here. Okay, so this is input, this is output, and this is the hidden layer, right? And this propagation, right, goes through over multiple iterations. But in logistic regression, it happens, one or two iterations only. Okay, so what you are seeing as this, right, logistic regression is the building block for what is known as a neural network. Okay, that is the most advanced form of machine learning called as deep learning. Remember, I mentioned this while explaining, the concepts, right? Deep learning is a subset of machine learning. So deep learning is advanced, we're essentially talking about neural networks. That is how my brain processes. In fact, the way I described is how brain is actually processing the information. It is just that the level of complexity in the brain is high. How does that happen? Like, let's say, for example, you are looking at an object, right? You are looking at the screen. This is maroon color, right? You know that. How does your brain know that it is maroon color? Certain neurons are there. So many neurons are there in my brain. Certain neurons are firing. Okay? Certain neurons are not firing. And even the ones that are firing, they are not firing fully. Some are firing fully, some are firing partially, just like the weights. That is why we say that this is neural network. Just like how we will process, our brain process, what I gave as an explanation is our current understanding of brain. Okay, maybe brain is more complex because when you see an object, it is all neurons, right? Not all neurons will fire for a particular object. Only a certain set of neurons will fire, certain set of neurons will fire partially, and certain neurons will not fire at all. Right? That firing, not firing, partially firing can be corresponded to the weights that I'm showing here. Right? That is what is known as a neural network. If I do this over many iterations, I have what is called as a neural network. Okay, what I am trying to do is I'm trying to simulate the artificial, the neural network, right? I'm trying to create that in my computer program. Clear? That's why the word, artificial intelligence, everything comes in. Okay. So enough of theory, right? Just a few more things that I was trying to explain, right? So error is nothing but predicted minus actual. So this is represented by a cost function. Okay. So this evaluates the performance of our machine learning algorithm. Okay. The loss function computes the error. Okay. And over multiple training examples, the average of that is your cost function. So the goal of any machine learning algorithm is to minimize this cost function, which is nothing but the error, which is nothing but the extent of false positive and false negative. Okay, this is the gradient descent that I was trying to explain. Okay, why the word gradient descent is. Suppose you are at the top of the mountain, right? You have just been born into this universe. Okay, just like our algorithm. You don't know whether to come down or go up, right? Whether to come this side or this side because you have just been born, right? Or when you are here, you don't know whether to go, you have to come down, you don't know whether to go up or go down, right? That is the dilemma the model will have, right? If you have to find the weightages, should I give higher weightage or should I give lower weightage? But still, we either come down or go up, right? Somehow make a start. That's why we say that this is like a gradient descent. Okay, it's an iterative optimization algorithm used to find the minimal value, right? Which is basically lower false positive and false negative. Okay, so now let's get into an example. So much for theory. Any doubts on what I explained? Any questions? Okay.
So how to use that gradient?
Descent, right? See, you don't need to
Yeah.
worry about that, right? If you have to write a program, that is very complicated, right? If you have to explain. So for us, sklearn library is there that has made our lives easier. You're just going to call logistic regression just like how you call linear regression.
Okay.
Okay, that entire library will contain all the steps that I explained. Okay.
Okay.
Sure.
Thank
So now we are going to, similar. I have stored this file right in Google Drive. I have validated the auth code, right? My content is mounted. I am reading, okay, the file. Here I am using the publicly available Titanic file, right? Whether someone, survived or not depends on passenger class, whether that person was male, female, and age, right? Because people who were pulled out first, essentially, the kids were uh, pulled out, then women, and then men, and even among men, the age was a factor, right? So that's why, and also the passenger class, right? The class divide was very high during those times, and then whether that person survived or not. So now, what are we going to do here? This male female is a non-numeric. I must first convert this into numeric, right? So for this, I use true or false Boolean, right? True means 1, false is 0. I have encoded. You can use the encoder function or you can use this also, right? Especially when you have 1 or 2, right? Kind of, like male, female, good, bad, yes, no kind of scenario. You can use true or false itself and encode, right? Now I have done. I am defining my x's and y, and then the process is the same. Okay, so I import my test train split. Okay, then I import logistic regression, and if you see here, I am doing area under the curve. Okay, and I'm also doing this confusion matrix. This is your confusion matrix. Right? 117, 22, 24, 60. Right? My accuracy is about 80%. Accuracy is what? Basically, false positive, false negative divided by everything. Right? One minus that. So 117 plus 60 divided by 117 plus 60 plus 24 plus 22. This is my accuracy. This will be a ratio. I multiply by 100 to get 79.3%. Right?
Yeah.
I can also find the area under the curve, right? 0.834. This tells me how good is my fit. Remember the area under the curve that I showed here? Here we are getting 0.72 or something, right? Moderately accurate. In fact, what we are going to see subsequently, right? Two other algorithms, decision tree, random forest. They can also be applied to the scenario that we just saw, right? Whether someone will survive or not. This is also yes, no. Decision tree and random forest. Two more algorithms. In random forest, we also going to introduce some variants, okay? Random forest and logistic regression are the go-to algorithms in the world of business, okay? With that, you will be able to solve more than 95% of the problem. If your data is in numbers, right? Numbers and like yes, no, region, nominal and continuous data, these two will suffice. Only when you have images, you have to go for deep learning. Otherwise, what I'm covering is more than sufficient. NLP, as you can see here, is at the intersection of three disciplines: computer science, artificial intelligence, and human language. At its core, NLP is about how to program and analyze natural language data. When I say natural language data, I'm referring to the way you and I speak, right? That is the human language. We anyway have to do programming, only then this process can be automated, and we'll be borrowing the concepts of artificial intelligence, things like pattern recognition in machine learning and deep learning. So that's why this is at the intersection of three disciplines. NLP is concerned with the interactions between computers and human language. When humans interact with one another, we are using language, right? So the system is going to engage just like a human being, understand the language, and it is going to provide meaningful inferences to us. That's what makes NLP a very, very interesting field. So what are the applications of NLP? As I said, NLP is a very, very interesting area. It is used in doing sentiment analysis. If you are getting feedback from customers, you want to know what extent of the feedback are positive, what extent of the feedback are negative. That can be done automatically using an NLP application. The world of chatbots, right? It is based on NLP, right? Because in chatbot, you are engaging with customers, you are talking, right? You're chatting with the bot, right? All that is NLP. An interesting area that is emerging of late is how to convert speech to text, right? We can even analyze what is being said, right? So the speech is converted to text and that is analyzed. So that is also an application of NLP. Spam detection, right? In emails, we get a lot of spams, right? NLP can very easily and very effectively identify spam mails and filter them out, right? Autofill, right? That you're seeing here. You type a part of the word, the system guesses as to what is it that you're trying to type. Okay, so that's autofill. That is also based on NLP. Last but not the least, when you have a document and you want important information culled from the document, right? Important information like name and other details. That is also NLP, right? What is called as named entity recognition. We will be seeing that in the course of this session, right? If you see in this image, right? I want my name, my organization, people whom I like, and where I'm from, all these information to be called out, okay? And by the way, I'm Govind. I'm just going to introduce myself shortly, okay? So all these are wonderful application areas. And the key point to note is this technology is alive and kicking, right? You're not talking of a technology that's going to be there in future. It's already there and it's deployed at scale in many organizations. So when I say scale, I'm emphasizing that we are not talking of applications that are deployed on proof of concept scenarios. Okay, these have been tested and are now in full-blown applications. Having seen what is NLP and what are the applications of NLP, let's quickly understand what are the challenges in NLP. Okay, if somebody says, I want all the restaurants within a 5-mile or 5-kilometer radius, I'm referring to restaurants, right? Here, the word restaurant is explicitly mentioned. On the other hand, if I say, show me some close by locations, close by places to eat, I'm still referring to restaurants, right? The third option, display food places nearby, I'm referring to restaurants again. So my system should be able to understand these different scenarios, right? And correctly suggest what is it that I'm looking for. In this case, it's restaurants, right? So NLP involves addressing these challenges. So this is a challenge and also an opportunity, right? It depends on how you look at it. So we will go through the different aspects, different characteristics that need to be taken care while building an NLP application, right?
Now,
We are going to see the key concepts in NLP like lemmatization, parts of speech, etc. Okay, so let's get started with segmentation. So what is this segmentation? In sentence segmentation, we are trying to break the sentences or paragraphs that are given for understanding and interpretation by the system. We are breaking this the paragraph into multiple sentences so that the system or the software can understand the context and the meaning and provide us the necessary summary or inferences or whatever be our objective, right? So for example, if I had a paragraph like Diwali is one of the important festivals in India, the day celebrates triumph of good over evil. People light lamps and burst crackers to celebrate Diwali. Okay, so there are 3 sentences in this. Just like how a human mind will process a paragraph. How does the human mind process this information? Without our knowing, intuitively, we are breaking this into multiple sentences so that this can be understood. Because it has become like second nature for us, we don't really understand or we don't realize the breaking up of a larger paragraph into multiple sentences. We don't realize that. Okay, we don't realize that process. It is the same exact process that the NLP system will also do, right? The NLP system breaks the paragraph, which consists of multiple sentences, okay? It breaks them into individual sentences, which can then be understood and processed, right? So the NLP system will break this paragraph into Diwali is one of the most important festivals in India. The next sentence is the day celebrates triumph of good over evil. And the third sentence is people light lamps and burst crackers to celebrate Diwali, right? This is how the sentence segmentation will happen. Okay, the next one is called word tokenization. In sentence segmentation, we are breaking it into multiple sentences. In word tokenization, we are breaking the sentence into separate words. So this is the next step, right? We have broken a larger paragraph into multiple single sentences. Now we are going to deconstruct that sentence into multiple words. For example, if I had the sentence as Seaport AI, that's my company. Seaport AI is an AI company offering AI solutions in the areas of risk, customer experience and automation. Risk, customer experience and automation. If you see, using word tokenization, I have broken this into multiple words, right? And you see even the full stop is appearing here, right? But if you notice, words like the and right, they are not figuring in the word tokenization. See, it removes those words, right? Because those words are not needed for processing or understanding, right? They are there as part of grammatical structure, but other than that, they are not needed really to understand, right? So word tokenization breaks the sentence into multiple words and it removes words like and, the, and such words. Having seen that, now let's get into stemming. Okay, stemming helps to normalize words into a root form, right? Because when you have words like intelligently, intelligent, intelligence, or for that matter, celebration, celebrating, celebrated, right? If you see that, stemming is trying to form the root word, because once the root word is understood, you can then make inferences, understand what is being said, right, and do all the processes, right? So the aim of stemming is to identify the root word, right? But the problem with stemming is sometimes it gives a root word which doesn't have any meaning. For example, in the intelligent, intelligently, intelligence, that I told, the root word is intelligent, right? But unfortunately, intelligent doesn't have any meaning, right? So how can it really process, right? So that's the problem with stemming. Sometimes it produces words which have a meaning. The root words will have a meaning. Sometimes the root word it produces do not have a meaning, right? So that is stemming for us. So you may wonder if it's not able to produce the root word with a meaning, right? Why do we use it? Right? So we have another aspect of NLP which addresses this challenge, right? Called lemmatization. Lemmatization is built on stemming, right? Because everything needs to have a base, right? We first started with stemming and now we have lemmatization. Because lemmatization, if you see, is quite similar, right? And here also it tries to produce a root word called lemma, right? Only difference is lemmatization will ensure that the root word that you produce has a meaning, right? Why have two separate things still? Because there will be situations where we need to find the root word, the real root word, because in lemmatization some kind of approximation will happen, and you may end up with a root word which may not be the real root word of what we are trying to discuss, right? So we will have both lemmatization and stemming, right? And depending on our need, we will use this, right? So please understand that in stemming, the root word that is identified in some cases will not have a meaning, okay? Whereas in lemmatization, that disadvantage is addressed. Okay, so that's the difference between stemming and lemmatization. Okay, so having seen these four concepts, let's see identifying stop words. You see, even in the earlier example, word tokenization, these stop words, right, is the, right, they were removed, right? It's important that we remove them before doing any statistical analysis, right? Because understand, it is a system that is processing, right? Even when we listen, when we process, okay, we don't really process stop words. It is words like, in the case of he is a good boy, we are processing he, right? Good boy, right? Is are stop words, right? It's important that we remove the stop words because they do not have any meaning, right? Also note that people, when they talk, they use a lot of stop words, right? They use stop words as fillers. So stop words per se do not have any meaning, right? So it's important that we remove them, especially when you're doing things like sentiment analysis. You want to find out what percentage of customers gave positive comments, what percentage of customers gave negative comments. In such scenario, I want to focus only on the important words, right? Not on stop words. What is the use of knowing how many times a customer used is? It's not of any use, right? So identifying stop words and removing them is an important aspect of NLP. Moving on, dependency parsing. So dependency parsing is used to find how the words in a sentence are related to each other, right? It is like saying he's a good boy. Both are stop words, right? He, good boy. The three words are there. So I can write boy, good, he, right? It's not having any meaning, right? It's important that the system understands the relationship of the words, right? If the relationship among the words is not understood, the whole context is lost, right? So please understand this. This is a very, very important concept. Yes, we are breaking down the paragraph into multiple sentences, a sentence into multiple words, but I want my system to understand the relationship so that the right inference or meaning is drawn out of the sentence. So dependency parsing is also an important aspect of building the NLP pipeline, right? The next one is understanding the parts of speech, right? Like noun, verb, adverb, adjective, right? It's important that the context is understood by the system, right? If you're saying Google for NLP, Google NLP on the internet, is it a verb or a noun, right? Sometimes it can be a noun, sometimes it can be a verb, right? When you're referring to an activity, we are talking about a verb, right? Google, when I say Google NLP for let's Google to find out more about NLP, right? So there, I'm not saying Google as a noun, I'm saying Google as an activity, right? Let's use Google. If I say let's use Google to find out more about NLP, there I am using Google as a noun, right? So understanding these parts of speech, right, helps us to put words in a context even better, right? So these concepts, right, helps us to break the paragraph sentence, into words, understand the context, remove the stop words, right? Understand how the words are related to each other. You also understand whether it's a verb, noun, all those things are understood so that you can process them and make right inferences about what you're trying to analyze, right? So these are the basic building blocks of NLP, basic concepts, right? So having seen that, in a subsequent session, we will see how to program, how to write a program for each of these concepts. So we will cover that, okay? So when we do that, we will revisit these concepts once again, okay, so that it acts as some kind of summarization for you as well, right? So in the next session, we will see the challenges and ambiguity in NLP. That is also an important aspect, right? So we will conclude this session on the concepts, key concepts of NLP, or rather the basic building blocks of NLP.
We will get started with Python from this session. We have already installed Google Colab either in your mobile or you are accessing it from your browser. Whatever be the option, let's use Colab. This is an example that I already covered. Okay, this example is also something that we saw as part of, I showed these two examples as part of introducing Colab, right? So these are the other set of commands that I'm introducing. If you see, there is a command which is actually starting with hash. Okay, this is not a command per se. Okay, this is a note for us. This is telling us as to what is inside the set of codes. This is like a note that we write, when you're reading a book or when you're preparing for exams, you take notes, right? So this is like that. In fact, this is a best practice when it comes to programming. I encourage you to use this hash and provide a comment, because let's say you are practicing today and after a while, if you go back to the codes, you won't understand, right? Because time has passed. So this hash and this note really helps you to recollect and understand what is being coded. The other advantage is if your code is used by someone else, this acts as a good reference. Okay, without this hash and this note, it really becomes difficult to follow what is being coded. So please keep this in mind. Okay, and whatever you write after hash will not be processed by Python's development environment. Please keep this also in mind. Okay. So we saw this hello world. Now I am introducing x equals 8, y equals j. Okay. These x and y are variables. We are going to see that in more detail in the next session. For now, we will just try to print, okay, these 8 and this word j. Okay, I printed 8 and j. And note here, I can either use a single parenthesis or a double parenthesis. I am also telling x equal to double parenthesis j is the same as x equals single parenthesis j, right? In both the scenarios, j is printed correctly. In some programming languages, the variables with names, right, it will process only when single quote is there or a double quote is there. Okay, Python allows both the options, right? You can either have a single quote or a double quote, right? Okay, here I am trying to print, x equal to j, x equal to j, only the difference is the number of quotation marks. I printed print of x and I got j correctly. Okay, here I am inducing an error to demonstrate the use of Colab and also to show how to structure this command correctly. Okay, print I am giving without parenthesis. Okay, now if you see and if I process it, it says missing parenthesis. Did you mean print x? So easy, right? It's telling you have to use print x in parenthesis, right? It's not only telling you that there is an error, it is not only pointing where the error is, it is even telling what you should be using. How beautiful, right? That's the power of Colab. In this session, we will learn about variables. What are variables? We already saw that in the previous session, right? Here, x and y are variables. So in this session, we will understand these variables more in detail. Okay, a variable name, it can either be short like a and b or x and y, okay, or it can be a more descriptive name like weight, school name, college name, and stuff like that. Okay, please note there are some rules when it comes to declaring variables or naming variables. Okay, a variable name cannot start with a number. It can start with a character. It can be alphanumeric. It can even start with an underscore, but it cannot start with a number. So please keep that in mind. Okay, and variable names are case sensitive. If you have three variable names, age, capital A-G, all caps age. Okay, these are three different variables. Okay, you need to keep this in mind. If you don't take care of these things, the development environment will flag an error. Okay, and we can also find what is the type of variable. Okay, if a equals 6, the type of a is integer. All I need to do is type. Just like how you will converse, right? That's how the programming language is going to be. Okay, type of a. Here it is j. It is a name. Here it is a number, right? So this is non-numeric. In fact, it belongs to a type called string. Okay. When it comes to numbers, we can have integers, float, and complex. Integers are numbers without decimal. They can be positive or negative. Float is primarily a decimal number. It can also be scientific. Okay. What is the scientific number? I can write 100 as 10 to the power of 2, right? So that's a scientific representation of a number. Okay. This is ideally used for larger numbers. You can also have complex numbers. They typically end with j. Okay. If you see here, a equals 5, b equals 2.3,
C is 1j, and I am trying to find the type of each of the three variables. Okay, I get integer, float, and complex respectively. Okay, and I can also convert one type of variable into another type. For example, x equals 5, right? That is, it's an integer. Look at the way I am using hash. I can write hash like this also. Okay, please note this will not be processed by the development environment. Okay, why am I giving? As I indicated earlier, if you refer to this course, or if you refer to your codes after a while, you won't remember it, right? Okay, now let's convert. I'm converting from integer to float. Here x is 5, it's integer. What I use the type of number to which I want to convert x, right? Float of x is all I write, and it gets converted as 5.0. Similarly with 6.8, that's a float. I convert float into an integer. All I write is b, this is a new variable, b equals integer of y, int of y, right? And it gets converted as an integer. And I also validate that with checking for the type of a and b. Is this clear? Very easy, right? Okay. And as I indicated earlier, you can have strings either as a single quotation or a double quotation. So we have seen string and numeric type of variables. Now let's see Boolean. Boolean will have either true or false. Okay, you can even compare a condition like this. Okay, here I am comparing, is 8 greater than 6? It is true, right? So true gets printed. Is 100 less than 160? That is also true, so it gets printed. Here what am I checking? Is 5 equals 6? When I put two equal to's, it means I am checking, right? I am checking, is 5 equal to 6? 5 is not equal to 6, right? So it prints false. So we use Boolean either as a standalone variable or for the purpose of comparing a condition. In both the scenarios, Boolean is used. But please note, Boolean returns either true or false. Okay, so it can have only one of two values, right? The other point to note when it comes to variables is you don't need to declare the type of variable before you start assigning a value to it. In other programming languages, you have to first declare what type of variable it is. In this case, you have to first declare that a is an integer type of variable, and only after the declaration that you can start using that variable or start assigning a value to that variable. In Python, this is not needed. Okay, Python, if you declare a equals 5, Python will assume that a is a variable of integer type. This is done automatically. You don't need to declare a variable before you start using or assigning a value to it. Okay. In this session, we will see the different types of operators that are used in Python. You can have arithmetic operators, right? These are used to do different types of arithmetic function. You can do an addition, you can do a subtraction, you can do a multiplication, you can do a division, you can do exponentiation also. That is, 100 can be represented as 10 square, right? So this is an example of exponentiation, right? X to the power y. That's what this does. Okay. What is modulus? Modulus is the remainder. For example, I am dividing 9 by 2. 9 by 2, 4 times, and the remainder is 1, right? If I divide 9 by 2, I will have 4, and then I will have 1 as the remainder. So modulus will return the remainder. Okay, modulus will return the remainder when two numbers are divided. Okay, I can have comparison operator. I can compare two things. We saw that in the earlier session also.
This is for comparing whether the two variables are equal. If I use an exclamation mark and an equal to mark, it means it is not equal. Okay, this is greater than, less than, greater than or equal to, or less than or equal to. If I merely use a equals 5, this equal sign, this is known as an assignment operator. That means I am assigning the value of 5 to a. If I use two equal to signs, it becomes a comparison operator. So please keep this in your mind. Okay. Logical operator, right? Here I am comparing two statements, right, or two conditions. Here, only if both the conditions are true, I will get a true value, right? Here, even if one of the conditions is true, I will get the result as true. Okay, and not is an opposite of any of the two, right? I can have not for and or also. Okay, for example, if x is, let's say, 4. Okay, if x is, let's say, 4, is 4 less than 5? True. Is 4 less than 10? True. So the result is true, right? Here, if I have, let's say, let's use the same 4. Okay, if I use 4, 4 is less than 5. Is 4 less than 4? That is false, right? 4 is equal to 4, right? In this case, this is true. In this case, it is false when x is 4. But because I use r, okay, even if one of the conditions is true, it will return a true. Got it? Not is opposite of that. If I were to take x equal to 4, not of this will be a false, right, which is opposite of true. I can use not, as I said, even for or also. Are you getting it? Okay. I can also have membership operators. Suppose, let's say I have an array. I can check if a particular sequence is present or not. Okay, is x in y or is x not in y? Okay, that is membership operator. Okay, I can also have identity operators. Let's say I have an array. For example, I can write Chennai, that's a city in India, Beijing, London, New York. Let's say this is an array. Okay, what is an array? We are going to see. Okay, for a moment assume that this is some kind of a database or a data set. Okay, I can even assign it to a variable, calling it as a. I can check, is Chennai part of this? Is Los Angeles part of this? Okay, here it will return a true or a false. So please keep this in mind. You can also check, is x is not y. Okay, not just x is y. Are you getting it? So I have an array, I have a data set, I am checking whether something is part of it, whether something is not part of it. So that's when we use an identity operator. So we have different types of operators that will be used depending on our requirements. Clear? This session is about conditional statements. We will see how to use conditional statements in Python. It is like if today is a weekend, I will play, else I will study. That's a conditional statement, right? We will try to bring the same type of conditional statements in our programming. If you recollect, we saw this example right in the beginning of the session when I was introducing Google Colab development environment. This is a conditional statement, right? I'm comparing two variables. If b is greater than a, I want to print b is greater than a, right? What are the different types of logical conditions that can be tested? Is a equal to b? Is a not equal to b? Less than b? Less than or equal to? Greater than? And greater than or equal to? In all these things, we are talking essentially about an if statement, right? If a is equal to b, you do this. Like the example I said, If the weather is sunny, I will go out and play, else I will stay at home, right? And the if statement is written by using the if keyword. You see, we have used the if keyword here, right? We also have something called as elif. What is elif? It is if condition is not true, this is the next condition we want to be tested. We have two variables. We are first checking if b is greater than a, right? Print something. This is obviously not true, right? So we want the program to go and check the next one, that is elif. There also we are checking, is a equal to b? That is true, right? So this will be printed. Okay, it is Python's way of saying if the previous condition were not true, then try this out, right? This is elif is the short form of else if. Okay, then we also have something called as else. What is else? Else correspond to whatever that has not been caught by previous conditions. I start with if. If this is not true, I want this to be tested. If both are not true, then what should the program do? That is else, right? Else caters to anything that is not caught by the preceding conditions, right? We have if, elif, which is the short form of else if, then we have else. So we have three things when it comes to conditional statements, right? I can also write if, elif and else, using this short form, right? I have two variables. I will print x if a is greater than b, else print y. I'm coming straight to else. Can I have elif? Yes, you can have elif also, right? And I can have one more else. Are you getting it? So I have if, elif and else. Okay, three things to test different conditions in my program. Okay, and I can bring and or conditions also, right? I'm comparing two things. Is a greater than b and c greater than a, right? Or is it a case of a greater than b or a greater than c? In this, both the conditions have to be true. Here, at least one of the conditions have to be true, right? And I can have elif, else also as part of this, right? That's what happens, in real life, because you will have multiple scenarios to consider. Are you getting it? Okay. I can also have what is known as nested if. What is nested if? If condition within an if condition, right? Let's understand this example. I am assigning a to 18. Okay. A is a variable, numeric variable, integer, a equals 18. The first condition I'm checking is a greater than 10, right? That's true. I'm also checking is a greater than 20, right? This gets printed. This is true. Above 10. This gets printed. After that, the program will come to this line. You are now going to check for this condition. This is not true, right? So it will come here, else. Print, but not above 20. Are you understanding the concept of nested if? Right? I can have if, it is like having a condition within a condition, right? This is how the conditional statements are used in real life. I wanted to cover all the possibilities here. Okay. We will understand about loops in this session. What is a loop? Something gets repeated over and over again. If we want some kind of action to happen over and over again, we use loops. In Python, we have got two kinds of loops. Okay, one is a while loop and for loop. In while loop, we execute as long as a condition is true. Okay, whereas a for loop is about iterating over a sequence. That could be either a list, a tuple, it can be an array, it can be a string, it can be anything, right? So we will see both while as well as for loops in this session. Okay, let's understand while loops using example. As I said, while loop is about as long as the condition is true, I want some action to happen. Here I want a print command to happen, right? I start with I equal to 1 as long as I is less than 10, I want the printing to happen, right? We will start with 1. After that, what happens? The next statement is we want I to be incremented by 1. This is nothing but I equals I plus 1. I am resetting the value of I with an increment of 1. That's what is meant by I equals I plus 1, which is denoted as I plus equal to 1. Okay, so I am incrementing I by 1, which is I is equal to 2. So 2 gets printed, right? Then this becomes 3, 3 gets printed. This becomes 4, it gets printed. Like that it goes. When it becomes 9, I gets incremented, right, by 1. I becomes 10. Then while I is 10 only, this can hold true. When I is equal to 10, we need to stop this. That's what has happened, and that is why this particular set of commands has printed only till 9. Right? Now we will see one more example here. Here we want to exit the loop when I is equal to 4. Just like in this example, we are starting with I is equal to 1. And the condition we are checking is while I is less than 5, print I. Right? 1 is printed. Then the other condition is I equal to 4? That is the next condition we are checking. That is not true, right? That means there won't be any break. We will go to the next line, which is I is incremented by 1. I equals I plus 1. So I becomes 2, right? So I come here, I gets printed, I is less than 5, so I gets printed. Is I is equal to 4? No, right? I is incremented by 1, I become 3. Then when I come to 4, okay, I print 4, and is I equal to 4? This is the condition that we are checking. What is the command we have given? Break. That means we need to stop executing. That's what we are telling the computer, break. Break means break the loop, right? So that is why only until 4 the development environment will print. Are you understanding while loop? Okay. Let's also see for loops. Okay. For loops, here I am considering an array. Okay. We have got orange, mango and grapes. For x in fruits, it need not be only numbers. It can even be non-numeric like this, right? This is a string, right? For x in fruits, print x, one after the other is printed. I can also introduce conditions as part of for loops. Okay, just like I introduce a condition in a while loop. While loop itself is a condition, but on top of that I introduce another condition, right? This is like a condition within a condition. That's what I'm doing. For x in fruits, that means we are starting with orange. Is x equal to mango? No, right? So if x is equal to mango, you need to continue. That's what is x? You are starting with orange, right? Is x equal to mango? No. Is x equal to mango? Yes, that means continue. You go to the next one. So grapes are there. Mango won't get printed here. Because what we are saying, if x equal to mango, we are telling continue. That means go to the next one. We are not saying break. Right? Here I am using the break command. Let's see how it works here. It is similar to this, right? For x in fruits, print x. If x equal to mango, break. What do I say? I start with orange. Orange gets printed. Then mango gets printed. And I am saying when x equal to mango, break. But here I am saying continue. That means I say go to the next one. Are you understanding? Are you understanding how the world of loops work? Right? I can also have nested loops. Right? If you see here for x in fruits underscore features, right? That's a one array. Fruits is another array. I want to print like red orange. All I have to do is print x comma y. Red orange, red mango, red grapes. Then big orange, big mango, big grapes. Then I have tasty orange, tasty mango and tasty grapes. Right? So I have nested loops also covered here. Okay. In this session, we will understand about functions. Functions is a very important concept in programming. and it is equally applicable for Python as well. Okay, functions are used whenever reusable aspect of code is there. Whenever any repetitive actions have to be performed, we invariably use function. Okay, there are two types of functions. One is a predefined function, the other is a user defined function. As I said, in both these scenarios you have reusable codes, right? Certain codes, certain lines of codes are again and again used. Okay, user defined function is local to you. That means it is available only to you in a particular program. That is the program in which you have written the function. Whereas predefined functions like NumPy and Pandas are available to everyone, right? It comes as pre-installed libraries, right? So they are predefined functions. They are available to anyone who is using Python's development environment, right? So we will have both of them, predefined as well as user defined functions. In fact, one of the reasons Python is so powerful is it has many predefined functions for many activities, particularly for machine learning and deep learning activities. You don't have to write many lines of code to do a particular task in machine learning. You just have to call a particular predefined function and your job is done, right? Because functions make your life a lot easier and they help you to organize your code better. I will go to the extent of saying even if a single function, okay, is not there in a program, that means it's been written by an amateur or a very inexperienced programmer, because the use of functions is a best practice when it comes to programming. Okay, so functions will be there in any set of codes, right? Because you will have repetitive activities. That can be anything, right? So let's use functions. Let's reuse the code to the extent possible. Here I have demonstrated an example, right? I have created a function to add numbers. Yes, we have plus sign here, right? But I don't want to use this plus sign. I just want to say add 5,6 or add a, b, right? I want the two numbers to be added and even printed. Okay, so I have created this particular set of codes for the function add. So whenever I want to add two numbers, all I have to do is I have to mention add a, b, right? Which is add 5,6. The two numbers will be added and you will have the result, right? And I can use this within my program any number of times. So I don't have to write these 3 or 4 lines of code. All I have to do is mention add of a, b. Add of, let's say, 3, 4, 7 will be printed. Add of, say, 5, 8, 13 will be printed, right? It can be any two numbers. Are you understanding? And please note, this is available only to me because this is unique to me and this is unique to my particular program. If I want to use this function in another program that I write, I have to define the function and only then I can use it. Predefined functions like NumPy and Pandas are available to all the users of a development environment of Python, and all you have to do is you have to import this NumPy and Pandas. How to import that? You're going to see that in the subsequent sessions. Okay, and once you have imported, that particular set of codes is available to us, right? And as I said, Python comes with many predefined functions, especially in the areas of machine learning and deep learning. Okay, let's learn about arrays in this section. Arrays is a data structure that comprises of different data elements. The data elements can be numeric or non-numeric, as you can see here. This is an example of an array. Okay, if you see here, we have arranged the data in the form of rows and columns. This is how data is stored in a database, right? I am showing an example of student record, student database, right? So I have serial number, I have roll number, I have name and age. So this is an array. Python has got 4 different types of arrays, and we are going to see each one of the array in more detail. But let's understand what are the 4 different types of arrays. The 4 different types of arrays are list, tuple, set and dictionary. I have created this table so that you can understand the difference among the 4 different types of arrays easily. Okay. If you see, list and tuple are ordered, that is the elements in that array are ordered. Okay. Set and dictionary are not ordered. And in tuple, once you have created an array, you cannot change it. Okay. Set and dictionary do not allow duplicates, right? I cannot have another entry 5 roll number, Ramya 5. Okay, this is an entry, right? I cannot have another same type of data in set and dictionary. Set and dictionary do not allow duplicates. Okay, an index, that is how you will refer this particular record or any record in computer memory. Okay, that is done using index. Set will not have an index. Okay, and how will you create the arrays? You will use these different types of brackets. If I use a square bracket, Python automatically knows that it is a list. You don't need to declare the variable as a list, right? We saw that even earlier also. Tuple, you will have round. Both set and dictionary will have curly brackets. Okay, so understand these primary differences. We will go over each one of these arrays in more detail in subsequent sessions, right? So essentially, array is a collection of different data elements, right? It can be numeric or non-numeric. We express the array in the form of rows and columns, but I can have unidimensional array also, because this is a 2-dimensional array, right? I can have a single dimensional array also. And the 4 types of arrays are list, tuple, set and dictionary, right? And you need to know the differences. This is very, very important concept. Okay. If you are planning for a career in machine learning, or if you are keen to learn machine learning, the concept of arrays is very, very important. Okay. Even otherwise it's important, but it's doubly important for those interested in learning machine learning and deep learning concepts. Okay. We will start with the list type of array in this session. Okay. So let's create a list containing red, green, yellow. If you see, this is a single dimensional array, right? And what is the 0, 1, 2? These are the index values. Okay. Where red, green and yellow are stored in computer memory, they are referenced by these index values. And index values typically start with 0. Okay. And if you see this, I am starting with this hash. Okay, this is a note to me, and anything that I write after hash is not processed by Python. Okay, so I am creating a list. In fact, I am using the variable name as sample list itself, right? Just another list. It can be anything, or you can even have a or city name or whatever, right? Or color. So I have red, green, yellow, and I am trying to print it. So I have red, green, yellow. Okay. Because I have these index values, I can refer to the index values like this also, sample list of 2. That means yellow will be printed. Okay. And I can have negative values also, right? -1 is the last item and -2 is the second last item, right? I have yellow and green. Understand? Simple, right? Okay. I can also add an item to this list, right? I have red, green, yellow, and I add black. Okay, for this I use the keyword append. So all I need to do is sample list dot append, and I mention what item to be added. I mention black, and black gets added. Okay, but if you see, using append, whatever I mentioned got added in the end, right? That is after yellow. What if I want to add this black right after red? So I need to mention the index value. So if I mention like this 1 comma blue, blue will go between red and green, right? And I can also remove an item. For this I use the keyword remove, right? Here I mentioned remove black and black goes away. Okay, so I'm left with red, blue, green and yellow. Clear? Okay, I can also delete a specific index or entry. Okay, I am deleting. In the previous one you saw, I deleted by mentioning the name here. Here I am mentioning the index value. See, this is what I have now. Now I delete what is there in 0. So red is removed. So I have blue, green and yellow only. Okay. So I can also create another list from an existing list. So all I need to do is use the word copy. Okay. And I can also delete the list. Okay. Or clear the contents of the list. What is the difference between the two? If I use clear, the whatever I have mentioned, red, blue, green, yellow are removed. Okay. If I say delete, this is removed and what is there as sample list also goes away. So if I have to create new entries, I have to first create the sample list and then have these entries. So deleting is like deleting an entire file and clear is removing the contents of the file. Okay. So with that we complete list. We will see tuple, that's another type of array, in the next session. We will see tuples in this session. In the previous session we saw list. Okay. Just like list, tuple is also an ordered set. Okay. It allows duplicates and index values are also there. But a key difference between list and tuple is that tuple, once you have created an array, you cannot change it. Okay. In fact, this is the only type of array where changes are not allowed. And you can create a tuple using round brackets. So please keep this in mind. Okay. So we will create a sample tuple just like we created a sample list, right? Sample tuple is the variable name. I have India, Singapore and Canada. These are the three values that I am having in my tuple, right? So I created using this type of bracket. I don't need to declare the type of variable because this is Python. Okay. And then I am printing print sample tuple. India, Singapore and Canada are printed. I can also use index values, right? I can use a positive value or I can go the reverse way also, right? Here sample tuple of -1, the last record is printed, right? That is, and you can have sample tuple of 0, that is India is printed. Okay. I can also have scenario like this where I want to have items from 0 to 2 to be printed. But please note, whenever we give like this, the last item is left out. Okay, when I give 0 to 2, ideally I should have India, Singapore and Canada also printed. But when you give like this, the last item is left out. So please keep this in your mind. Okay. And if you want to change in a tuple, how will you do it? It is not possible, right? Tuple doesn't allow any changes. But what if you have to make a change in a tuple? So what you do is you convert tuple to list first, make the change and then reconvert that list back to tuple, right? So what I do, sample list, I'm creating a new one. I'm creating from a tuple, I'm creating a list. So if I give like this, list of sample tuple, the tuple is converted into a list, right? The variable name is sample underscore list. I want to make the change at the first index value, right? So instead of Singapore, I want to have UK. So sample underscore list of 1, I will give the new value of UK, right? and then I convert the list into a tuple, right? And when I print the new tuple, okay, I have India, UK and Canada, right? Okay, I can also iterate, okay, using for x in sample tuple, print of x. Okay, we will have a separate session on iteration and looping. Okay, and I can also check. Remember, I mentioned about this when I was discussing different types of operator. I can check if Canada is there in sample tuple, right? I'm checking Canada is there in sample tuple, and then I say print Canada is there. Okay, yes, Canada is there, right? Not yes, Canada is there. Canada is there will be printed. Okay. So once a tuple is created, you cannot add items because tuples are unchangeable. Can you create a tuple with just one item? Yes, you can. Okay. Only thing is you need to give a comma after the first item, right? Otherwise, Python will not recognize it as a tuple. And because tuples are unchangeable, you cannot clear. You cannot use the command clear like what we saw in list. You can only delete. That means the entire array goes away. Clear? I can also create tuple using tuple constructor, right? And I can join two tuples using join or plus operator. That is also possible. Okay. This session is about set. In the previous sessions, we saw list and tuple. Now we are going to see set. Unlike list and tuple, set and dictionary are unordered. They don't allow duplicate entries. But a key aspect of set is it is not indexed. Okay. So please keep this in mind, and it can be created using curly brackets. Okay. So unordered, unindexed, because they are unordered, you don't know the order in which the items are stored, right? If you try to print a set, each time it will print the elements in the set in a different order because the sets by nature are unordered. Okay. And you can't refer or access the items using an index also, right? Because sets are unindexed. Okay. You can use other methods like loop, or you can search for a keyword, but you cannot access them using an index value. So please keep this in mind. This is something that's unique to sets. Okay. So let's start creating a sample set similar to what we did in list and tuple. Okay. Here we are considering 3 cities, Manila, London and Chicago, right? And then we print sample set. See, the order is changed. Okay. I had Manila, London and Chicago, but when I try to print, the order is changed. When you try to print again, it will probably start with London. I can also use a loop like this. Okay. And I can use a membership operator in to check whether Manila is there in the sample set or not. Okay. Note that it will return a Boolean value, true or a false. Okay. Now let's see some additional actions. If you want to add one item to a set, use add. Okay. If you want to add more than one item, use the update method. You must know these things so that you can play around with different options. Okay. Some more additional actions for you to consider. To remove an item in a set, you can use either a remove or a discard. If the item to remove is not there, remove will raise an error, whereas discard will not raise an error. You must know these two subtle differences. Now to remove an item, you can use pop also, right? But sets are unordered, right? So you will not know which item is going to get removed. Okay, so you be prepared for that, right? And clear will empty the set, similar to what we saw before, and del will delete the set completely. That means, it's like the entire file is deleted. Okay. Now let's see how to join two sets. Okay. I can join two sets using union, or I can also use update. Okay, when I use union, it'll both the sets will get added like this. Please note, sets are unordered, so we don't know what is the order in which the new set will appear. So you must be aware of this, right? I can, as I said, I can also use update. The only thing is, in update, the common entries will be excluded. That is, in this, what is the common entry? The common entry is 2, right? So 2 will not be printed twice. 2 will be printed only once, right? Whereas if I use union, 2 will appear twice. When I use update, 2, which is a common entry, will appear only once. Okay. Lastly, I can create a new set using the set method, right? This is similar to what we saw in list and tuple. Okay. We have seen 3 types of arrays so far: list, tuple, and set. So this session is about dictionary. So dictionary can also be created using curly brackets, and it doesn't allow duplicates. It is changeable and it is not ordered. Okay, so please keep these things in mind as we go about creating a dictionary. Okay, and we will print the dictionary also. So here we are trying to have a label for each of the data elements, right? Like name, class, and age. Okay, and we are printing the student underscore dict. So this is the variable which contains these elements. Okay, and we will try to do some more operations in the dictionary. Okay, we are trying to print the name, and we are trying to print the age. And see here, we have created a new variable, and we are assigning the value of name to this variable and age to the variable b. Okay, and we are trying to print a and b. Okay, and in this example, I am trying to change of class, okay, the value of class from level 5 to level 6. How will I do it? So I have created it here. Okay, this is student underscore dict. This is a dictionary that I have created, and I access the class and I mention the value of class is level 6, right? In this case, there is only one record, so it's easier for us to change the value. All I have to do is I have to reference the label name, okay, and give the new value, and the new value is taken. Okay, and I can add an additional item also in this. Okay, I have name, class, and age. I want to add sex as male. So I give the additional item to be added here, and that is mentioned. And when I try to print the student underscore dict, I have the dictionary that is printed. Okay, with the new item also. With that, we have completed the arrays topic. So we covered 4 different types of arrays. Always refer to this table, because this can be a ready reckoner for you, so you can clearly understand the differences among the 4 different types of arrays. Okay, let's get started with NumPy from this session. NumPy is a pre-built library. Remember, we discussed about user-defined functions and predefined functions in the function session. So NumPy is a predefined function that comes with the Python development environment. So when you download Python, NumPy is available. You have to import it. We are using Google's Colab as the development environment. So NumPy comes pre-installed. So you just have to import NumPy. Okay. So NumPy stands for numerical Python and is a library used for working with arrays. Okay. We already covered arrays. We saw 4 different types of arrays. So you may have a doubt as to why we need NumPy. That is because the traditional arrays like list, tuple, and all that are a bit slower to process, especially when it comes to large data sets. That's where NumPy scores over. Okay, and NumPy is used frequently and extensively in the world of AI, ML, and deep learning. Okay, so let's get started with how to import NumPy. Okay, so you will import NumPy like this. You just say import NumPy, and the pre-built library is made available to us, right? You can also import NumPy as NP. NP is like a short name or an alias. Okay, I can import NumPy as NP also. See, Colab is actually suggesting this to you. Okay, so once I've imported it, the functionalities associated with NumPy are available to us, right? So NumPy comes with a lot of functionalities for working on arrays, and they are faster, right? Which is why we are using NumPy. So here if you see, I am creating an array. AR is a variable, okay, numpy.array, or I can use np.array. What are the elements in that array? 1, 2, 3, right? So array is the keyword here. Okay, 1, 2, 3 is printed. I am trying to print when I imported NumPy as NP also. Okay, both the scenarios will work. You can use import NumPy or you can use import NumPy as NP. Once you have created an alias or a short name, you can refer to the NumPy library using the short name itself. Okay, do you understand this? Fine. So here if you see, there is an error. Okay, what did I do? I am trying to create a two-dimensional array. If you see this example, I created a unidimensional, single dimensional array. Here I am creating 1, 2, 3. Should ideally have been 4, 5, 6. Instead of that, I made a mistake. 4.5.6. Instead of a comma, I used a dot, right? So that means this is an invalid number, right? It's an invalid syntax. So Colab is clearly highlighting this and it is showing in red. Once I corrected this, okay, it is printing correctly. If you see here, this is 1, 2, 3, but here there are only 2 elements. It accepts it. It is perfectly fine. But there is no such number called 4.5.6. And hence, this was flagged as an error. Clear? Okay. Now let's try to understand the concept of ndim. Ndim tells the dimensionality of the array. Here I am creating 4 arrays, okay? np.array. Here there is just one element in the array. This is 1 dimensional, this is 2 dimensional, and this is 3 dimensional. So to know what is the dimension of the array, all I have to do is the respective variable name dot ndim. But before using all this, I must have imported NumPy as NP. Okay, the NumPy should have been imported. Clear? Is this clear to you? Okay, and I can use the concept of index value also. So I have created an array. I am trying to print the index value 1. Okay, the index value 1 will correspond to number 2 in this array, right? Because the index value starts with 0. 1, 2, 3, 4, 5. The storage location, index location will be 0, 1, 2, 3, 4. So what is there in 1 will be 2, and hence 2 is printed. Okay. I can also access details, using the index value for a 2-dimensional array, right? All I have to do is array variable is there 0, 2, right? That corresponds to 3, and 3 is printed. I can also have negative in this, right? All that we discussed in array is equally applicable here as well. And I can give like this also, and it will print all the values that are there from index location 1 to 5, but the last one is excluded, right? Ideally it should have printed 2, 3, 4, 5, 6, but because the last value has to be excluded, it printed 2, 3, 4 and 5. Clear? Okay. And if I want to print all the elements that are there from index value 5, it will print all the remaining ones 6, 7, 8, 9, 10, right? And I can do the other way also. Here I am printing the array elements from 5. Here I am printing up to 3, right? And I can give step function also, that is the alternate element in the array is printed starting from 1 up till 5. The last one has to be excluded. So I print 2, 4. Easy, right? Here I am trying to create a new array from an existing array. I have two options. One is copy and the other is view. And after I have created, I am trying to change the first element using the index value, right? AR of 0, that is this, I am changing to 6 in both the scenarios. And then I am trying to print the original array and the newly created array, right? If you see, copy owns the data, whereas the view does not own the data. So in the case of copy, because it owns the data, the original value is retained. In the case of view, the original value is not retained. It's only the changed value that remains. Clear? We will continue with NumPy, and in this session we are going to see the concept of shape in arrays. Okay. Shape basically is about the number of elements in each dimension. So let's first create an array. Okay, we are going to import NumPy as np. This is the first step, right? And then we are creating an array. Okay, a two-dimensional array, and there are 5 elements in each dimension. To know this, all I have to do is ar.shape. It will return the number of elements in each dimension. That is 2 dimensions and 5 elements in each dimension. 2, 5, right? All I have to do is variable name of the array dot shape. Okay, and shape is the keyword here. So now let's see how to reshape. Okay, so reshape is the keyword here. First I have created an array. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 elements in the array. I am converting that into 5 by 2, that is 5 rows and 2 columns. All I have to do is ar.reshape 5, 2, and it reshapes this array into a 5 by 2 array, right? Okay, now let's see one more example in reshape. Here I have taken the same array and I am trying to reshape into an array 3 rows and 2 columns, 3 by 2 array. Okay, what do you think about this particular set of commands? What will get printed? You can take a moment, you can even pause the video if you want. What will be the result? The result is, it will be an error. Why? Because I cannot convert a 10 element array into a 3 by 2 kind of array, because the dimensionality will be affected. I will be left with elements that cannot be fitted into a 3 by 2 array, right? So look at the error you are getting. Cannot reshape array of size 10 into shape 3, 2, right? And the error is in this line. It is primarily a dimensionality problem. Are you getting it? Whereas I can convert this into a 2 by 5 or a 5 by 2, right? I can convert that, but I cannot convert a 10 element array into a 3 by 2, right? 3 by 2 will accommodate 6 elements. What will happen to the remaining 4? That cannot be accommodated, right? Okay. The next one is flattening, right? Flattening converts a multi-dimensional array into a one-dimensional array here. Okay, we use the keyword reshape. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, a two-dimensional array. I am bringing it down by one level here, so I will have a one-dimensional array, right? So reshape -1 will create this one-dimensional array. Clear? Okay. In this session, you will understand about how to join arrays using NumPy. We are going to be using concatenate to add two arrays. Okay, first we will import NumPy as before, and then we will use concatenate to add the two arrays. Okay, if you really see in SQL, okay, which is the language used in databases, we join tables based on a key. A table is an array, right? In NumPy, however, we join arrays by access. If access is not explicitly mentioned, okay, we will take it as access is 0. Here access is not mentioned, which is why access is taken as 0, and you have all the elements like this 1, 2, 3, 4, 5, 6. Here I am explicitly mentioning access as 1, right? So I have created an array 1, 2, 3, 4. The next one is 5, 6, 7, 8. Because I have mentioned access as 1, it is printing as 1, 2, 1, 2, 5, 6, and then 3, 4, 7, 8. Is this clear? I can also join arrays using stack. Okay, so here also I mention the access. If access is not mentioned, the default is taken. Okay, so I have created an array like this. When I add, okay, np.stack, it creates 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. Okay, I can also add along rows. That is the advantage with stack. Okay, if you use hstack, you can add along rows. That is horizontal stack. vstack is vertical. See here, 1, 6, 2, 7, right? It gets added vertically. dstack is along depth or height. Okay, that is similar to what we had here. Okay, all I do is dstack. For vertical stack, vstack. For horizontal stack, hstack. Right? So you can use either stack or concatenate to join arrays. Okay. Just like how you can join arrays, we can split arrays also. Okay. So let's see how to split arrays using NumPy. Okay. So here we have two options. One is array underscore split or split. That is, I use np.array underscore split or np.split itself. Okay. First I have to import NumPy, right? Import NumPy as np. That is the starting point anyway. Okay. The key point you have to notice, if I had used split here, okay, instead of array underscore split, I would have actually got an error. Okay. Whereas array underscore split has worked fine. You have got an output. That is because split will not adjust the elements, right? When dimensionality has to be taken care, split will not adjust the elements. Okay. Whereas array underscore split will adjust the elements when dimensionality issues are there. Okay. That is the key difference between array underscore split and split. Okay. Just like how we had hstack and vstack, right, and dstack, we have such options available in split also. Vertical split and dsplit are available. That can also be used to split the arrays, right? Okay. We will now see how to search and sort arrays using NumPy. Okay. For searching, we will be using the keyword where. How will we use where? We will use np.where. That's how we are going to use. Okay. And here we have multiple options available. We can search for a specific element in an array, or you can even search for odd and even, right? How will you use where for determining an odd number, an even number in an array? We will use the concept of modulus. Remember modulus? We covered that earlier, right? As one of the operators. Okay, as one of the arithmetic operators. So this x divided by y. Let's say we are dividing 5 by 2. Okay. What is the remainder? Remainder is 1. So I am checking if the remainder is equal to 1 or the remainder is equal to 0. In the case of odd, the remainder will be 1, and in the case of even, the remainder will be 0. Here we are dividing the array element by 2, right? Makes the job easier. Okay. How will you sort arrays? We will use sort as the keyword here. Okay. So I have an array like this. I am sorting np.start. AR is the array element here. Okay, array variable. Sorry. I can also sort where there are characters, right? Here these are strings, right? Basically, and the sorting will be based on alphabet. Okay, so I have orange, mango, and grapes. When I sort, I will get grapes, mango, and orange. Okay, here the third example, I am trying to sort a two-dimensional array, right? So what do? I first add the array and then I sort. That's how you can sort a two-dimensional array, right? Okay, good. So with that, we conclude the NumPy section of this program. We will continue Python with pandas in the subsequent session. Just like NumPy, pandas also helps us to work with arrays, and pandas is even better compared to NumPy. Okay.
Welcome to the session on pandas. Pandas are similar to NumPy. Just like what we saw in the previous sessions, pandas also help to create arrays. In addition to creating arrays, we can understand different aspects of the array. We can understand aspects like what is the mean, what is the standard deviation of data elements that are present in an array. As I said, we are trying to identify patterns, and patterns are identified by studying the characteristics, and characteristics are existing in the form of, or characteristics are explained using numbers, and numbers are stored in the form of arrays. So we saw how to create arrays using tuple, dictionary, list, and all that. We also saw how to create arrays using NumPy. NumPy is numerical Python. As an extension of that, in today's session, we are going to see how to create arrays using pandas and how to manipulate the arrays. Okay. Pandas is in fact a high-level data manipulation tool. Pandas is Python data analysis library. This is a pre-built. Just like how we called import NumPy as NP, here also you will import pandas as PD, and then you will start using the various commands that are available as part of the pandas library. It is built on the NumPy package, and its key data structure is called as a data frame. A two-dimensional array, which you are going to see, is called a data frame. Okay, data frames allow you to store and manipulate tabular data. Okay, the data that is stored, in the form of tables in various databases, they are stored as columns and rows, right? I have student name, I have student marks. Okay, it's a typical data frame. So data frame almost creates the kind of data, creates the way in which data is stored in databases. So you can manipulate data, you can infer data, you can identify patterns from that. Okay, so pandas builds upon functionality that is provided by NumPy. Okay, so both belong to a stack called as SciPy. Okay, scientific Python, a set of Python libraries used for scientific computing. Remember what I said in the previous sessions. Python provides a lot of built-in libraries, especially to analyze data, analyze numbers. That is why Python is so powerful. This kind of pre-built library is not available in other programming languages. Of course, it is available in another programming language called R, Okay, but Python has got its own advantages. But compared to things like Java or C or C++, right? Pandas is a wonderful library. Okay, and it is a pre-built. So what I mean by pre-built, when I say it is a pre-built library, I mean it is already available. You're just going to import and you're going to start using. You understand? So remember what I said in the previous session. Okay, I can create an array using a tuple command. I can create an array using um, using NumPy. I can create an array using pandas. It depends on the appropriateness, right? So that's how we need to look at these opportunities, these options that are available to us. So which is better? People invariably talk, is NumPy better or pandas better? Okay. If you see, pandas and NumPy are core to a lot of data analysis. NumPy actually consumes less memory compared to pandas. We also saw that, it is faster. True. Okay. But normally NumPy performs better than pandas if the number of rows are 50,000 or less. If the data volume is more, right, more than 500,000, 5 lakh records, 500,000 records, right? Pandas generally are better. So pandas come with this powerful object called data frame. You're going to see that very shortly. It's a very powerful library. Okay, it's a very powerful object. It helps in analyzing data very, very easily. Okay. Pandas works when data is in a tabular format. Okay. Whereas NumPy works well when data is just numeric, right? Real life storage of data, okay, that is stored in databases is actually in tabular format, which is why pandas is very helpful. How data is stored in databases? We saw relational databases, right? Data is stored in relational databases. How are they stored? They are stored in the form of tables. Pandas actually recreates the tables. Okay, so it works very well, for data in tabular format. That's why pandas are very helpful. Okay, pandas offers two types. Okay, series is a one-dimensional array. Data frame or DF is a two-dimensional array with labels. Okay, in this session we are going to see data frame, right? Because we have seen a lot already in series, right? One-dimensional array. Because two-dimensional array is what you will encounter in real life. Data frame is a key concept for practitioners. If you are planning to take up employment, if you're planning to attend interviews, this is a very, very important concept.
In this session, we will create a data frame and do some basic processing. We will be using an example that all of us can relate to.
So let's create a data frame. Data frame of student, right? So this is a table. This is how data will be stored in databases. This is in the form of a table, right? What you see here, 0 to 11, this is index. Okay, it has got name, age, and also grade point average, right? So how do I create? See, I have put hash, as I said, reinforcing the best practice. So data frame is how records are stored in real life databases. So pandas is a very powerful library. Okay, so we are creating a data frame, right? We are creating a student data frame. Okay, so in this you have what you see here. This is index. What you see here is index. What you see here is the student record, right? I have name, I have age, I have grade point average. Ram, James, Ritvik, Vidya, all of that, right? I've got 12 records. So how do I create? I import pandas as PD. Before that, I create this using hash. I'm creating a data frame. Okay. Remember, this is the best practice that I have been saying from the beginning, right? It helps you to organize your code better. So if you see this, I'm importing both, pandas as PD, numpy as MP, because I don't know when I'm going to use both. Okay. So let's download both. And then I am creating, using this keyword pd.series, right? Age, GPA. I am giving the label also. See, in one shot, I have created a table like this. Okay, I'm calling it as A. This is the data frame, and you can print the data frame also. Very simple, right? If I have a bigger data set, how will you print it? How will you type it? You don't need to type it. Let's say you have it in the form of an Excel. You can access the Excel also. That is the beauty of pandas. I can upload the data from where I have stored, right? If let's say you have say 50,000 records, will you be printing 50,000 names, 50,000 age, 50,000 GPA? You won't do that, right? Because someone would have already entered and kept it for you through some other operation. The table is already ready, so you're just going to import it. That option is also possible. But what you are seeing is you're manually creating. You can upload and get the data also. Okay, but for now, let's stay with, we have created a data frame by manually entering the names and other details. Okay, and now let's start with the basics. Okay, I will first print out, what are the different types. Name is an object, age is an integer, GPA is float. What is the difference between integer and float? I'm saying this is float, that is decimal points. In the case of integer, it is a round number. Okay, Ram, is the character that I'm talking about. Right, so that's what I'm doing first. And if I want to print first two records, okay, all I have to do is df.head 2, right? If I want to print last three, tail of 3. Clear? See this, the first is Ram, James, Ritvik. This is Advait, Beena and Shreya. Ram and James. Clear? Why do I need it? When you have thousands of records, you will want to know what is there in the record, what is there in the table. I don't have to go through each and every record. I want to quickly see what is there. So I use this command. Right? I just want to see what is there. I just want to see, you're seeing a sample. Oh, this is how it looks, is it? Okay. Because you could be importing from different, databases. You could be importing from an Excel. You have a fair idea of what is there, but you actually want to see what is there in it. You want to just sample it. For that, you use these commands. Whenever you get a data, you must look at some basic descriptive statistics, right? That's what you can see for this. When you give data frame.describe, it gives my basic characteristics. How many are there? Okay. See, it is calculating for the numeric only. If you see, there is one more column called name. It is not counting for the column because that is character. It is only calculating for the numeric type. It says there are 12 counts. Yes, there are 12 counts. It says what is the mean, which is the average. What is the standard deviation? What is the minimum? What is the maximum? What you see here, 25, 50, 75, they are called as percentiles. Okay. What is there in the 25th percentile? Okay. What is there in 50th percentile? Some of the competitive exam scores are scored as percentiles. Right? In a competitive exam, if someone says, I have scored 90th percentile, what does that mean? It means I have, in a class of 100, I am actually at 90, 89 people are below me. So only 10 people are above my rank. You have a list of people, let's say list of marks, you will organize it in descending order, organize from bottom to top to bottom. And let's say you are at 12th rank. It means you are at 88th percentile. That is 87 people are below you. Only 12 people are above you. So that is the concept of percentile. Okay. So you need to see all of this. Right? Instead of doing manually saying counting, manually doing standard deviation and all that, one single shot, right? One single command. You are having all the details. See how easy it is, right? It's making our lives easier. That's the beauty of Python, as a language. That's the beauty of libraries. There are many, many libraries available. I can find a mean. Okay. If I put mean, I get what is the mean for age, what is the mean for GPA, and it also tells me the float. I can find mean only for a specific column. Okay, when you say mean, okay, without specifying the column, it prints mean for all the numeric values that are there. But here you can specify only for age, I will compute the mean.
In this session, we will continue with the same student data frame example and attempt multiple data manipulation activities.
So if I want to transpose, I got it, if you see, column wise. And now I am transposing. All I have to do is df dot, that is rows become columns, columns become rows. I'm flipping it, right? Sometimes I want to see this way also, all as part of manipulation of the data. Okay. I can sort based on age. This is an ascending order. If you see, this is the original data frame we created. What you see here, this is the original data frame. And what you see here, this is a sorted data frame. All you have to do is data frame sort underscore values. Clear? Makes life a lot easier, right? I can also sort by a condition. If I sort by age, what you saw, this is the original and this is what you got. Can you see the new index is the index 0 to 11 remains, but what is stored in 0 is different now. In this one, in the original data frame, what is stored in the 0th index is Ram, but what is stored in the 0th index is Vidya. And now I have to get 1 to 4. 1 to 4 is 1, 2, 3, 4. Why it is printed only 1, 2, 3? We saw that even earlier. The 4th won't be printed. It will only print 1, 2, 3, one less. Understand? Ways of manipulating the data. I want to print only, I want to select only name and age. I want to leave out GPA. I can do that also. I can remove age from my data frame. That also is possible. All you have to do is data frame, name, comma, age. That's all. Nothing else is needed. Another way of accessing is through iloc. That's another way. through the index value. Remember, the fourth is not printed. It's only James, Ritvik and Vidya. Steve is not printed because it is fourth. It is normally 1, 2, 3, 1, right? You can copy a data frame, and you can create another data frame using copy keyword. The same thing is created. Sometimes I want to create a copy because I want to manipulate and see. So that's how this is helpful. Okay. What if I want to update a data frame with a new value? What is there in the 0th index? I want to change the age. This is the original data frame. Ram's age is 19. I am accessing the 0th index. It is this. I am accessing this. Through this, I am replacing the age. 19 becomes 20. Now see this here. So I can update a data frame also. In this, I can add a new column. See, I've got name, age, GPA. You have different groups, right, in schools. I belong to green. I belong to, it's called as house also, right? Green house, yellow house, red house. I think I'm taking you back to schools. Like this, I can have different departments, different states. And once it is there, all I'm doing is I'm adding a new column group. That's all. Group equals. And then I'm adding here. It goes and gets added in the end. And you can add in the middle also. That option is also possible. Okay. Now, having added, I can group my data frame. See here, I am grouping all greens. I can group all red. I can group all yellow, right? I can group all green. I can group all yellow. If I want to group employees who are working in HR, want to group employees who are working in finance, I can do that, right? And if I want to find, having grouped, what is the mean? The age and GPA of green group is this, red group is this, yellow group is this. See, this is how you go and identify patterns, right? See, the green, yellow, red is one type of pattern. Do you all agree? Now, if I have a data frame, I have a data set in which grouping is there. I go and look for commonalities. And if there is a commonality like this, that is the first pattern for you to identify, right? That is the first commonality that you are going to identify. So you have green, red. So you have found a pattern. This is the first step. Can you see it? Programmatically, you have identified a pattern. And now you are trying to identify the characteristics of the pattern. In the form of computing mean, you can compute standard deviation, you can compute so many other parameters, so you can go on to solve a problem. Do you understand how everything is falling in place now? The objective in artificial intelligence, data science is all about finding patterns. And patterns are found by studying the characteristics. And characteristics are represented in the form of numbers. Hence, and numbers are stored in the form of arrays, tables, data frames. And we are manipulating the data frame. We are studying the data frames so that, we can unlock the mystery in the numbers. Through that, we unlock the characteristic of the pattern. And from there, we will understand the pattern. So, which is what we are doing here programmatically.
There is a saying that a picture is worth 1,000 words. We have so far learned to create data, analyze data, get insights about data. Now let's try to visualize the data, because visualization is a very powerful and very useful tool. For this we will be using matplotlib. Okay, that is one of the topmost libraries in Python. There are other libraries that are available for data visualization, but we will essentially talk about matplotlib because that is the go-to library when it comes to data visualization in Python. Okay, I am going to build on the data frame we created in pandas. Remember, this is the data frame we created for name, age and GPA. Now for this data frame, I am going to create visualizations. I am going to create a bar chart to start with. So what do? First I create this data frame, right? I import NumPy, pandas and create this data frame. Now for the purpose of visualization, I am importing matplotlib.pyplot as PLT. This PLT is the alias or the short name, right? Just like how we have NP for NumPy and PD for pandas. right? A single line of code gets you this bar chart, right? df.plot, what is the type of or what is the kind of chart you want? Bar chart. And then you are giving the details of x and y axis, right? You have the bar chart. Very easy, right? Do you want to create a line chart for this? Instead of a bar chart, if somebody asks you to create a line chart, how will you do? Think. All you have to do is, instead of bar, put line. That's it. Instead of a bar here, in kind, I choose line, right? That's all. I have a line chart. Very easy, right? Python makes our life a lot easier, even in data visualization. Okay, in other programming languages, you have to really struggle. Okay, single line of code giving you a wonderful chart like this is possible in Python. Okay, now we saw a bar chart, line chart. Okay, we can also create a scatter plot. Scatter plot shows the relationship between two variables. Here I am trying to establish a relationship between number of hours a student studies and the marks he or she obtains, right? This is the axis for marks and this is the axis for number of hours studied. Okay, suppose the student studies 0 hours, scores 30 marks, studies for 0.5 hours, scores 40 marks, studies for 1 hour, scores 50 marks, so on and so forth. Okay, but if you see, there is a progressive increase in marks corresponding to the increase in the number of hours studied, but beyond 3 hours there doesn't seem to be any relationship, right? Okay, even without me explaining, just by looking at this chart you can understand what is going on in the data set, right? That is the power of scatter plot. Scatter plot shows the relationship between one variable and the other variable. In fact, this concept is used in regression. Regression, you can study in detail when it comes to machine learning and deep learning. Okay, you can use this even outside of machine learning and deep learning also. You just want to understand the relationship between two variables, use a scatter plot, right? Okay, you can even join these dots. Those are other options that are available. Okay, but for now understand that scatter plot shows the relationship between two variables, and just by using plt.scatter hours comma marks you can obtain this. Okay, but make sure you import numpy, pandas and matplotlib before you come and run these codes. Got it? Now let's see one more chart, box plot. Okay, the advantage with box plot is we will know what are the extreme points in our data set. That is the biggest advantage with box plot. Okay, in this I am using the concept of creating random numbers also. Okay, because bar chart and line chart I used data from the data frame we created earlier, and then when it came to scatter plot I created a new data set, right? I created arrays here. Now for the purpose of creating box plot I am creating random numbers. First I import, right, numpy, pandas, matplotlib. Okay, I am also mentioning the kind of graph I am creating, right? Remember what I said, anything that you write using hash will not be processed by Python. So now I have imported and then I create random numbers. See, I'm including 4 different data sets, right? 1, 2, 3, 4. For this I am creating some number of random numbers. Okay, and for this I am creating a box plot. So what is, again, box plot is a keyword, right? If you see this box plot,
in data 1 and data 2, there are some points outside this line. These points are known as extremities or outliers. Okay. Understanding outliers is very essential when it comes to data science, or for that matter, any kind of analysis. Okay. This is very useful, right? Finally, I'll show how to create a 3D plot. Yes, you heard me right. You can create even a three-dimensional plot. A three-dimensional plot like the one I have shown here. So we are using same matplotlib here. Okay. But for the purpose of creating three-dimensional, we are using a toolkit from matplotlib. Okay. It's called Access 3D. Okay. So we will be using this to create a three-dimensional graph. I am using a scatter plot only. If you really see this, this is a scatter plot. See here, it's a scatter plot. Okay. It is just that the scatter I am showing in 3 dimension. Clear? Okay. So with that, we complete data visualization using matplotlib. Okay. Congratulations, you have completed the course. I would like to share a curated list of some of my courses for your reference. I am also providing this file as a downloadable resource so you can access these links easily. A complete list of all my courses is available in my Udemy's profile link. Thank you and best of luck.